Good morning, everybody. Hope you have had a good night's sleep. Welcome to the last day of talks for today. Tomorrow we are only going to have group presentations and discussions, which we're also looking forward to very much. Today we're having a few changes in the program. So at 11:30, instead of Lisa Schipper from Oxford, we're going to hear Dirk Rübbelke. And at 1:45, instead of Dirk Rübbelke, we're going to hear Imke Roden. So just a few swappings. Please remember to indicate your lunch preferences at the front desk if you haven't done so. You can do that in the coffee break. And now I'm happy to introduce you to Martin Quaas from the University of Leipzig, and he's going to talk about climate protection and biodiversity conservation. Thank you.
Good morning. Nice to see you here, and I'm happy to be here and present this topic on very broad topic, I would say, on climate and biodiversity conservation. I heard that you already had a rich and very interesting program, and happy to contribute to this. Yeah, I'm an economist at the University of Leipzig, and I'm working there. Or I also lead a research group at the German Center for Integrative Biodiversity Research, IDIF, where apart from the one economics group, there are mostly biological groups. So I present the work that I present and the science that I present here is largely interdisciplinary at the interface between economics and natural sciences, in particular biology. Yeah, this is a broad topic. I was thinking that I split up the topic in three issues, three perspectives. The first perspective is climate change challenges biodiversity, the case of marine fisheries. The idea here is that we consider humans using a living resource, in that sense biodiversity, the marine fishery, and then climate change affects the patterns of use by affecting the dynamics of the natural resource. Yeah, so that is the first perspective. Second perspective is we have climate change impacting humans in terms of shocks, like drought in a farming system. And then we think about how biodiversity can mediate those effects of climate on humans. And the idea here is to discuss how biodiversity can act as a natural insurance in the face of climate change. And then the third perspective is that humans trying to protect the climate and what is the role and interaction with biodiversity in that relationship. Yeah, so these are the three perspectives, something like 15 minutes each. The climate change and marine fisheries topic is that greenhouse gas emissions and climate change have, first of all, they have two effects on the marine ecosystems. One is the climate change effect, that the water temperatures rise in face of climate change. And the other is that the CO2 that is emitted into the atmosphere eventually dissolves in the ocean and leads to ocean acidification. And both have effects on marine fish populations in terms that they affect their habitat characteristics. This is clear for the case of coral reefs, where you have coral bleaching in the face of climate change, but in other habitats as well. They affect life history traits of individual fish, such as maturation or growth, and then they have effects at the population level, in particular on the reproduction, or called recruitment, in the case of fisheries. Yeah. Just one example that I will present in a little bit more detail, not very much, but a little bit more, is the Northeast Arctic cod fishery. That's a fishery up north. It's the most important commercial fishery in the northern Atlantic, biggest cod stock in the overall Atlantic, huge annual catches. I should say that in Norway, in the meantime, this is only the second most important fish because the aquaculture production of salmon is bigger now, even bigger than this huge fishery. Recently, the stock size and catches increased. One important change has been in the 1990s where the management dramatically improved and the fishing quotas have been set much more restrictive than previously. So I think this is clearly one of the reasons that the stock is doing well. But also environmental conditions have been favorable. And this may be due to climate change as well. So if one looks at the reproduction, and this graph shows some statistical relationship on the horizontal axis, we have the sea surface, the water temperature, a time series of water temperature. This is cold compared to the waters that we are used to. And this varied between something like a bit above 2.5 and up to a little bit more than 5 degrees Celsius. And on the vertical axis is the number of recruits, so the young fish of age 3, so the young fish that survived over the egg and larvae stage up to age 3 per ton of spawner biomass, so 1,000 recruits per ton. No, sorry, this is million recruits per ton of spawner biomass. And then you see the data points from 1950 until 2020, according to the assessments of the International Council for the Exploration of the Seas. And then if one does the statistical analysis, how the number of recruits relates to spawning stock biomass and water temperature, then one finds a clear, significant statistical relationship that is U-shaped. So there, it assumes a maximum at something like 4.5 degrees Celsius water temperature. And then beyond that, the recruitment is decreased. Yeah, so that's the typical pattern one finds for fish, that they have an optimum temperature. And here, in terms of optimum, in terms of the recruitment, at that temperature is maximum. And then you already see from the data, I didn't put the numbers there, but you clearly see that the water temperatures have been largely below the optimum value, largely below 4.5 degrees. So if you have moderate warming, a little bit more than 4.5 degrees, or if that increases to this cloud of points moves more towards the optimum, then we can expect on average more reproduction. The stock would be doing better. And this might be what we have, might be one explanation why the stock has been doing well in the past couple of years. Then if one plugs this into a model analysis, then one can look at how would the stock do under fishing, depending on the temperature. So these graphs show a kind of heat map. The color, the darker red, indicate a higher risk of stock collapse. And here we have again the January temperature, so as on the graph before. And on the vertical axis, we have the fishing mortality. So basically, that's a fraction, or that's related to the fraction of fish that is harvested from the stock. Yeah, and then one sees, and we have two graphs. One is under present conditions, and one is, or present conditions in terms of the pH of the water, and that is if acidification would proceed to levels that we expect in the first half of the next century. So when the atmospheric CO2 concentration has doubled compared to currently, and then one sees that depending on the temperature, the stock can stand a higher fishing mortality without a substantial risk of collapse. But if one goes beyond this maximum temperature, then the risk of the stock collapse is already high at usual fishing mortality. So this range is in the usual range. And before the 1990s, when the management improved, the fishing mortality was in this domain. Now it's more in this domain. But we see that if the temperature increase would continue, then this would already imply a considerable risk of stock collapse. And if we also take into consideration ocean acidification, there will be a considerable risk of stock collapse. So that is the most important cod stock in the North Atlantic overall. But if one looks more like what is the important cod stocks regionally for Germany, then it's in the Baltic and the North Sea, and this looks at the Western Baltic. That is the Western Baltic cod. That's the most important fishery the most important Baltic fishery for Germany, also for Denmark. The graph is the same as before. Here we see the temperature increase above current, and here we see the fishing mortality. And one sees that any temperature increase leads to a larger range of fishing mortality when there's a substantial risk of stock collapse. The Western Baltic cod is already beyond the temperature optimum in terms of recruitment, which means that any further temperature increase is bad. If one then would maintain a high fishing mortality, this would lead to a substantial risk of stock collapse. And then one can plug this into a model analysis where we include the costs and benefits of fishing, in particular in terms of the consumer surplus that derived from the consumption of fish, and also the producer surplus derived from providing the fish. And the third category that we are interested in the fisheries is the resource rent, so the value associated to the right to harvest the fish. And then here on the vertical axis, I always have this degree temperature increase above current. It was when this analysis was done. The most recent data that we had is for 2040. And then here we have a couple of lines that show how these various quantity in steady state would develop if one would have this temperature increase. And let's first look at the graph in the center. We have the peak number of recruits. That's this bluish line, and this resembles what I've shown and discussed before. The higher the temperature, the lower will be the recruitment. The lower will be the reproduction of the fish population, and this has repercussions on all the other quantities. Under optimal management, one would then have to reduce the catches because the stock simply is less productive. That's the green line. And nevertheless, even though one adjusts and reduces the catches, would optimally reduce the catches, the spawning stock, so the stock indicator, the indicator for the fish abundance in the water, would decline with ongoing climate change and temperature increase. There are two other respects where one would adapt fishery management. One is that one would reduce the fishing mortality, so one would reduce the fraction of fish taken from the stock overall. And the other is one would increase the mean age of catch. This can be done by increasing the mesh size of the fishing gear of the trawl net. Yeah? And still, in the economic viability of the fishery, even if one would adapt like this in optimal fashion, would be reduced. Yeah, this was talking about, in our model analysis, about optimal fishing. Let's look at the data. How has this fishery been managed in the past? We see that in the past, this is over time, starting in the 1990 until recently, the catches from the Western Baltic cod fishery, these were really high in the late 1990s, but they have steadily decreased. You see that the recreational fishery has been taking a substantial fraction of the total catches, and in particular the commercial catches have dramatically decreased. If one would then do advise as a fishery economist or fishery scientist, one would strongly advise to reduce the catches below those levels to let the stock recover and then allow a little bit higher catches later. So this is again over time. These graphs start now 2004 and go until recently. This shows the deviations of the TAC. That is the actual management. That is the total allowable catch, the actual limit to catches that has been imposed by the regulator. As a percentage of the advice, that is what the scientists recommend as a total allowable catch, and we see that almost consistently the actual regulation was far more generous in terms of what is allowed to be fished than it was the advice. I think for me as an economist, even more interesting is this graph, and for us as economists, it's even more interesting. It shows the landings as a fraction of the total allowable catch, and there's always this negative deviation, meaning that the landings have been less than the total allowable catch, and that means all this regulation was rubbish. It did not constrain the catches. The fishers would not have liked to extend the catches be above the actual ones. So then, of course, there's no need to regulate if it has no constraining effect on the fishery. So optimally, one would, in the face of climate change, reduce catches and adjust management, but the management was really bad and did not constrain catches in the past. Yes, please. Thanks a lot. Landings is what is actually caught from the stock and then landed, so brought to harbor. That is what is actually observed. In the Baltic fishery, one does not, I would not say one cannot, but one does not observe what is harvested, what is taken from the stock, but only what is landed. And that is counted against the total allowable catch. So basically, the monitoring and control of regulation happens at the landing site, at the harbor, and not on sea. The regulation since now something like 8 years is that it ought to be on sea, so there should be no discards, right? If there should be no fish that is taken from the stock and then thrown away, but this still happens to some extent. So the only thing, but the only thing we have data on is landings. And the combination of climate change and bad regulation has led to a situation where the stock is in a seriously bad shape, documented by this paper, led by my colleague Christian Möllmann, and then this was recently published, taken up in the media, and then of course they exaggerate. We don't think that this population will die out, become extinct, but it is really in a seriously bad shape, and partly due to the bad management, partly due to climate change. Okay, so this is from the German television, says that the cod in the Baltic Sea is threatened to go extinct. That from the local picture. Now quickly to the more global picture. Also globally, it's not the case that many fisheries are well managed. Here, this shows a map from a publication in Global Environmental Change 2016, shows the exclusive economic zones of the countries around the world and the state of marine fish stocks, indicated as in shades of green color, darker shades indicating a better state of the fish stock as measured by the FIS fishing indicator of the Ocean Health Index. That is a huge project from the University of California in Berkeley, or headed by the University of California in Berkeley, where they measure various components of what they call ocean health, among them the state of the fisheries. They also do this for the mariculture, means the aquaculture, the culturing of fish and seafood in marine waters. And then we, in the statistical analysis, we also use this mariculture. But first look at this data on the state of the marine fish stocks. And then we studied how this relates to economic and institutional variables, and I just want to emphasize two. One economic variable is the GDP per capita, so the state of economic development, if you want, in natural log, and that is indicated here for the countries in the data set in shades of blue. Darker shades of blue indicate higher log GDP per capita, and then if one does and then we have some further controls. For example, if this is a small island state and things like that. If we do this, the statistical analysis regress the state of marine fish stocks, in particular on the log income per capita, but also then on variables such as the number of neighboring countries, then we see that, and this done here for the marine fish stocks, but then also on the mariculture, kind of surprisingly, the richer countries don't do better in terms of their fisheries. Yeah, so there's no statistical relationship between log GDP per capita and the state of the fish stocks. If anything, then it's negative even, right? But what is significant is the number of neighboring countries. By contrast, the mariculture is just as we would expect as economists, the richer countries do better. So I don't think the reverse is true, but it might also be, of course, that the countries that do better in terms of mariculture are richer. But the number of neighboring countries, obviously, and this is how it should be, doesn't matter. This indicates clearly that the marine fisheries are subject to kind of a common pool externality, even at the national level. More countries, neighboring countries, meaning kind of more countries competing to catch the fish, and then they're in worse shape. That's the interpretation. So globally, this is really an issue, and countries are struggling to manage their fish stocks. And climate change may play a role in this. And to make that point, I'm taking here this study by the colleagues from Vancouver, where they construct an indicator that they call the mean temperature in catch. I've introduced before the idea that fish populations have kind of an optimal temperature, a temperature where they thrive best. And this is indicated here as those curves. These are for different species of fish, the temperature, how well they do under those temperatures. Yeah? For temperate regions, subtropical and tropical regions. Of course, for the tropical regions, the temperatures are higher than for the subtropical and temperate regions. And then they have a range of species that are harvested, where catch data is available, and they estimate, weighted with a catch, the mean temperature for those areas. And then if there's global warming, if there's sea surface warming, then some species are harvested less and some are harvested more. And then if that is the case, that those species that thrive under higher temperature now are more harvested in a particular region, then one would observe this by means of an increased mean temperature in catch. And that can, of course, happen. Well, fish, I've shown the examples of Baltic cod and Northeast Arctic cod, and then shown that those species do worse, or may do better or worse in the course of climate change, but they are not forced to stay there, right? They can move, and that is something what may happen, and then also may explain such a pattern of increasing mean temperature and catch. And actually the data from that study shows from 1970 until the the first decade of the 2000s. Well, first, this SST sea surface temperature is basically the water temperature anomaly, so temperature increase, and one sees overall, despite, of course, all the fluctuations, a trend of increasing sea surface temperatures. So that is something one would observe for the fisheries. And then here, the other axis is the mean temperature in catch indicator that I've just explained how it's constructed. And one sees this increasing trend, in particular in the early years in the time period, but then again, increasing trend in the early 2000s. So one really observes that relationship, indicating that fish stocks or fisheries, but of course, the interpretation is that likely the fish stocks are moving towards the higher latitudes, towards the colder waters. To conclude for that part, fish species do have an optimal temperature. With ocean warming and acidification, some at least will face serious threats. And there's no doubt that the management needs to react on this, be improved, and ideally reduce the catches. But we have seen for the Western multicod, so far we don't see clear signs of improved management there. For other stocks, such as the Northeast Arctic cod, management already has improved in the past considerably. So it's not always clear that management is bad. Sometimes it's improved, and then we see signs that the fishes are doing better. But in the course of climate change, management is further challenged by the moving fish stocks. This is why I've shown that the number of neighboring countries has a negative effect globally on the state of the fish stocks. Now, if they move, then this will for sure be even worse, that issue, right? If even statically, if countries compete for a fish stock, then they tend to do worse than if they manage those fish stocks alone. If they even can expect that the fish stock to move out of their territories, they have an incentive. They have reduced incentive to conserve that fish population, and that is also what we could observe in various places of the world. Brings me to the next topic, biodiversity as a buffer of drought risk in the rural tropics. That is a study led by my former PhD student Freiberg, who's now at the UBC in Vancouver. What they did is they took panel data from household surveys, more than 7,000 households from 300 villages in many developing countries around the world, the years 2005 to 2010, and those dots, those red dots, indicate the villages where those observations come from. This is throughout the tropical regions of the world. And then in the map, the shades of green indicate a biodiversity indicator. That's the number of wild species observed in those countries. And overall, if you look at that map, then you see that the tropics are the regions with the darkest shades of green. They are the biodiversity hotspots around the globe, so they are the areas where most species occur. And the household data, it's a panel. They do several rounds of the panel survey a year, and then they observe the incomes of those households from various sources in the harvesting seasons, in the planting seasons, and in the growing seasons. And then they study how those incomes depend, among others, on biodiversity, but not only on biodiversity, also on droughts. And this is where the climate change issue comes in. We expect from many countries around the world that in the course of climate change, weather becomes more extreme. So we would expect that there will be both more drier dry seasons and wetter wet seasons. So in particular, when it comes to drought, we would expect more drought. And then if you these graphs show the normalized coefficients of this panel regression on here crop income only, forest income only, other income only. These are the three categories of income they have in their database, and the total income is the sum. And if one looks at the drought, then you see the drought has a negative impact, significantly negative impact on crop income, forest income, other income, and then of course also on total income. And it is they also disentangled the drought in the different seasons, planting, growing, and harvesting season, and they find that in the harvesting season the drought is not detrimental, naturally so, right? But it is in the planting and growing season. One observation is that the drought in the growing season actually is positively correlated to forest income, which gives an indication that the households substitute. If they have a drought in the crop income, then they go and and harvest from the forest and obtain higher income there. Okay, but the interesting effect is the interaction between the effect of drought and biodiversity. And that is the overall effect on the various incomes. And we see that if you have a region with a higher biodiversity, natural biodiversity, then consistently this tends to decrease or increase the income, decrease the negative effect of a drought overall, and the interaction effect is positive on the total income. And it's particularly driven by the effect of biodiversity on crop income in the growing season, and less so by the effect on the harvesting and planting season. Overall, the result is that the negative effect of a drought on income can be mediated by biodiversity, and their conclusion is that a one standard deviation higher biodiversity than on average in the sample would fully mitigate the effect of drought on total income. So biodiversity in that sense can provide natural insurance. If one has more biodiversity, then for those rural households in tropical regions, this can help offsetting the negative effect on the drought on the various incomes in particular, and then also on total income. What does this mean in value terms? Well, this shows there is an insurance, but how valuable that insurance is another question. And yeah, if I have a couple of minutes, I would like to have a couple of slides on a more theoretical part, how to define and measure an insurance value of biodiversity. That can be done by applying expected utility theory. So that shows here as a function of the variable of interest, in this case income, the utility that one would obtain. And this is typically, the Bernoulli utility is typically considered to be a concave function that's indicating risk aversion. In what sense? Now, if income is uncertain, it can assume a low value with some probability and a high value in this simple example with a complement probability. Then we have this low utility in the case of the low income, higher utility in the case of a high income. And then we can also look at the expected income, and we can also look at expected utility. Let's assume that the probabilities are 50-50 to simplify things. Then expected income is just in the middle between the low and the high income. Expected utility is just in the middle between the higher and lower utility. Yeah? And then expected income corresponds to some level of utility at this expected income, and this utility at the expected income is higher than the expected utility, and that is what we say is risk aversion. If this household that is characterized by that utility function could choose between a situation where they would get the expected income for sure and the lottery, then they get the high utility if they would get this expected income for sure. And the income that would give rise to the utility, the expected utility, is called the certainty equivalent of income, which is lower than the expected income due to risk aversion. Whereas expected income can be objectively measured, the certainty equivalent of income cannot be measured by a survey like the one presented before. Yeah, I think that's an important element for the certainty equivalent. Risk preferences play a role. The difference between expected income and certainty equivalent is the risk premium. And it's the amount of expected income that an individual would be willing to pay to get rid of the income risk. And proper definition of an insurance value put forward by my colleague Stefan Baumärtner, and we have used this and further developed this in a couple of joint papers also, is that the insurance value is the marginal reduction of the risk premium with the variable of interest, in particular with biodiversity. So that would be then an appropriate value measure for the insurance value. Then if one can apply that and, for example, look at farming, where it has been shown by biological studies that a diversity of crops, but also a diversity of pollinators would stabilize crop yield. In particular, if you look at the diversity of pollinators sustained on a given farm, then those pollinators would also benefit the neighboring farms, thereby exerting what one can call a risk externality. Also, the other farmers would benefit from the stabilized yield. Yeah, and if one has this kind of risk externality, this increased pollinator diversity on one farm would also reduce the risk premium for other farmers and thus impose or have an insurance value for them. Okay. And then, for example, one can look at other forms of insurances, natural and in particular financial insurance, so crop insurance, for example, or other forms of financial insurance. They are substitutes for the farmer. This may have repercussions on how the farmer manages the land, and in particular, of course, the risk externality would need to be taken into account when designing payment schemes for biodiversity or ecosystem services. One question, the 45 minutes, would they include discussion or do we discuss afterwards? Afterwards. Okay, then I briefly go through a couple of more issues on the natural insurance value. The picture that I've just showed about the risk premium and natural insurance value was in a static picture, right? There was no time involved. But we've seen before, in the example we considered before, the fish populations, but also biodiversity. Those are natural capital assets. They develop over time. They can decrease over time. They can deteriorate if one treats them badly, if one overuses them. But they can also increase if one invests in those natural capital assets. The fisheries is one example. So the key point here is, they're all subject to uncertainty. We have seen for the data I've shown for the Northeast Arctic cod fishery, they're all around, right? There is no deterministic relationship. And the reason is that there are always environmental fluctuations and in particular climatic and weather fluctuations. And they give rise then to a stochastic dynamics of these natural capital assets, but the stochastic dynamics, so the things and the incentives to, for example, to conserve those stocks depend on the expected future benefits, future return of treating those stocks conservatively. Okay, so we are really in a dynamic environment where we would have to look at how such a stock would develop dynamically. So if you use S to denote the resource stock in the period T, or in this case T plus 1, then the future stock depends on, of course, the current stock. It depends on the extraction, the harvest from that stock, and it depends on stochastic shocks, for example, weather shocks, droughts, and the like. Then we can set up such a model. The S, the H, the Z can all be vectors. So this setup fairly generally can be described as several state variables. And we can, if we have such a model, a stochastic model, then we can set up the corresponding deterministic model where we switch off stochasticity by setting this random effect on stock dynamics to the expected value in all periods of time. Yeah, and one can use these two, the comparison of the stochastic dynamics and the deterministic dynamics to isolate the effect of risk on management, but also on the benefits derived from managing that stock. But that means we cannot simply stick to the picture of risk preferences, the two-dimensional picture of risk preferences that I've shown, but time matters as well. So we have to look at risk and time preferences. Not only the risk profile depends on how much biodiversity is there, how we treat the natural capital stock, but also the time profile depends on this. So we have to look at dynamic utility, dynamic expected utility, for example. That would be the expectation taking over future realization of uncertainty, discounted with some utility discount factor delta, value of utility derived from the income of using that natural capital stock, which depends on the quantity extracted, and it depends in general also on the respective current stock size. This U is an interesting function. It's the per period utility function, and in the standard framework, we would also typically think that this is a concave function, as I've shown in the graph before. And the key thing is that in this setup, the concavity of this function captures two things. One is the risk aversion that we have discussed, but one could replace this interpretation with the risk on the horizontal axis with a variation over time. And then similar logic would apply. And the curvature would measure then not the risk aversion, but the aversion against fluctuations of the income over time. And if you have this one function, the curvature of this function measures both the aversion against risk, fluctuations due to risk, and aversion against changes over time. The problem, this maximization optimization problem, can be formulated recursively. Yeah, if I go back, this V is the optimized value. It depends on the current stock size, and then we can also formulate this recursively. The V as a function of the current stock size is then by maximizing over the current catches or current resource use, the utility in this current period plus the present value of the expected future value. And the expected future value, we have to take the expected future value because the future stock size depends on stochastic shocks on top of what is the current stock size and how we use the current stock size. This is for the standard model. One can introduce a more advanced, more sophisticated model of time and risk preferences by introducing another function, this function phi. You see if the phi was the identity, or if it was simply a linear function, then it would simply drop out because of the linearity of the expectation operator. But if it's a nonlinear function, then it changes it changes the preference structure. So then not only the preferences are not only characterized by the properties of the U and the time preference rate, but also by the shape of this function phi. And the interpretation is, well, the phi is always assumed to be increasing. If it's linear, then it doesn't affect the preferences at all. But if it is concave, then the risk aversion is larger than the preference for intertemporal consumption smoothing, the preference for intertemporal income smoothing. And if it's convex, it's the other way around. Such a model for a specification where both U and phi are isoelastic, are power functions, is called Epstein-Sinn preferences. And this has been applied recently by those French colleagues to a model of biodiversity development in farmland, where they capture, or where they model biodiversity as a natural insurance. We in this paper use this to generally define a natural insurance value, and we do so by considering an ad valorem risk premium, as we call it, is the fraction of income that the resource manager, so the fraction of income that the research manager would be willing to sacrifice, so such that only 1 minus R times the current income would remain, and sacrifice in every year, so in every period, 1 minus R times the then current income would remain. And risk premium is defined by this equation, by this equality. I should also emphasize, would be willing to sacrifice in the deterministic natural capital dynamics, so in a setting where there would be no risk at all, in which case the resource user would be willing to sacrifice compared to a situation when there is stochastic resource dynamics. So the R, of course, the larger the R, the lower will be the present value from using that natural capital stock, because one gives away part of the income derived from using this natural capital asset. And there's one value where this value for the deterministic capital stock is just equal to the expected present value of utility derived from the stochastic natural capital stock. Yeah? And that is exactly the dynamic equivalent to the risk premium that I've introduced in the diagram before. And then the insurance value is defined, the insurance value of natural capital is defined by the marginal decrease of that risk premium with an increase in the corresponding natural capital stock. Yeah? Okay, you see that the definition of natural capital in a dynamic environment is more complicated than in the static environment, but it is kind of a natural extension towards the dynamic environment. And then we can see that if you have an isoelastic per period utility, the phi can be anything, this difference between risk aversion and intertemporal consumption smoothing. But if this U is isoelastic, then the optimal use of the deterministic resource would not depend on R. And then we have this ad valorem risk premium is a function of the current stock size of the resource. It's 1 minus the value, expected present value of utility from a stochastic resource divided by the expected present value of the deterministic resource, which is then simply the present value of the deterministic resource. That is always larger than the expected present value of the stochastic resource because of risk aversion. Yeah, so this is always positive when we have risk and risk aversion. And then if you can go further, if you have not only isoelastic utility per period utility, but a logarithmic per period utility, we can establish an equivalence. One would use the resource more conservatively if and only if the insurance value is positive. So if the insurance value is positive, one would use the resource more conservative. If the insurance value is negative, one would use the resource more aggressive. But this equivalence breaks down if one has non-logarithmic utility. Why? Because the insurance and intertemporal consumption smoothing, they then interact in a more complicated way, in particular if one has intertemporal complementarity relative to the log case, then one would rather not give up so much of the income in the future in the expected in the deterministic case than in the present, and one would tend to harvest the resource more aggressively, even though one has a positive insurance value. Okay, so biodiversity provides natural insurance. Natural insurance value can be captured by a change in the risk premium, both in a static and dynamic setting, but in the dynamic setting, one has to be a little bit more careful how to exactly define the risk premium. In dynamic setting, insurance and intertemporal consumption smoothing interact, but in the case of logarithmic utility, one still has this equivalence between natural insurance value and conservative resource management under uncertainty. Perhaps if I just wrap up a last topic in very few minutes, so I don't have a whole lot to present here, but I would like to come to this last interaction, humans trying to save the climate, and what is the role or what is the interaction with biodiversity. When it comes to saving the climate, we have to think about various techniques that are sometimes subsumed in geoengineering, but they can be distinguished, or climate engineering can be distinguished between radiation management, direct interference with the radiation balance of Earth, or interference with the carbon cycle, carbon dioxide removal, in particular, all these mechanisms to take out CO2 from the atmosphere, and then by this way reduce or reverse climate change. Among those carbon dioxide removal techniques is the so-called BECCS, bioenergy and carbon capture and storage. So the idea is to produce bioenergy. Well, replacing fossil fuels by bioenergy is a good idea in the first place, because for bioenergy production, the CO2 is taken out of the atmosphere and then released when the bioenergy is used. So this does not increase overall, in the long run, the atmospheric CO2 concentration, but it does not help to reduce past climate change, and this is why it needs to be combined with the capture and storage, so then taking out the carbon dioxide from the combustion of the bioenergy and storing it somewhere would actually reduce carbon dioxide concentration and thus reduce climate change. And in this IPCC studies how to achieve the Paris goals, BECCS, bioenergy and carbon capture and storage, actually play a major role. I don't think that those scenarios, P1 to P3, particularly not P1 and P2, are very realistic, because basically in 5 years' time, globally, the carbon dioxide emissions from industrial sources would have to be reduced dramatically. I don't see any sign that this would happen, not in Germany and not elsewhere, unless, of course, things like COVID now hits us every year and we are in complete lockdown forever. Then I think it's realistic. Otherwise, I think this at best, but this P4, but it comes with really serious amount of BECCS. This is assuming that there's no solar radiation management, of course. Now, if you look, BECCS, bioenergy, can be produced from agricultural crops. So far, it cannot produce in the ocean. There are some attempts, but it cannot. So likely source will be forestry. And this is the second last slide. If we look at the German forestry, timber harvest in Germany has been in last years something like 80 million cubic meters per year. Easy to remember. Per capita, 1 cubic meter per year is timber harvest in Germany. Every one of us emits 1 ton of carbon dioxide, 10 tons of carbon dioxide a year on average. 1 ton of timber harvested, 1 cubic meter of timber harvested is roughly equivalent to 1 ton of carbon dioxide. So the current timber, if you would just use this as bioenergy, carbon capture and storage, would mitigate 10% of our current carbon dioxide emissions. Total forest area is about a third of Germany. There is no way to use bioenergy and carbon capture and storage to fully offset German carbon dioxide emissions. I think this needs to be made very clear. But perhaps we can do it a little bit. Perhaps we can increase harvest a little bit, and in Germany also increase the forest area a little bit. Let's look at a case of a European beech forest like we have in Germany. Oh, damn it! And let's look at the trade-off between yield, here in this case revenues, but the graph for just yield in terms of biomass looks very much the same. And I've just seen that the label on the horizontal axis is missing. That's the biodiversity objective is the maintenance of old habitat trees. That's in forestry, one of the key biodiversity indicators. You need these big old trees as habitat for biodiversity, insects, and the like. And then you see that there's, of course, a substantial trade-off, in particular if you go for the more advanced biodiversity objectives. There's a clear trade-off between biodiversity and yield. Yeah, so to conclude, the Paris Paris Agreement's targets would require a lot of bioenergy combined with carbon capture and storage, unless, of course, there's solar geoengineering. But there are serious trade-offs with biodiversity. At the plot level, I've shown this here for the case of European beech. But of course, if we expand the area, there are also trade-offs. In particular, if you see that we also need to do something in terms of biodiversity protection, and in the European Union, particularly have the biodiversity strategy to increase area for biodiversity conservation to 30% compared to something slightly above 20% currently. So we face both crises at the same time, and this will be quite difficult. Thank you.
Thank you very much. We've got time for 1 or 2 questions. Yes, first one there, second one there, third one over there.
Thank you so much. Very interesting topic. The first question is about the income you used in different slides. Is it per capita income or national income?
Oh no, this is the income I used here is for the user of the ecosystem. Think of a farmer or a forester.
So only the farmer?
Yeah, this was, yeah.
Okay.
Yeah.
The second question is about we talked about present value, like determining the present value. What is the discounting factor here? Is it typical weighted average capital cost or typical discount rate in the market?
Yeah, that's what we usually use when we optimize forestry or fishery management. Yes.
So is it the same thing valid for this biodiversity future value calculation as well?
Yeah, in what I've shown for the optimal management of the forest, but also for the fishery, I've taken the same value. Well, currently we live in times when this is zero, right? So there's no big difference between market interest rates and social discount rates, I would say, currently. But of course, if you would go back to situations where the market, of course, the safe interest rate would increase, then this is an issue, and one would have to think about whether to use social discount rate or market interest rate.
Okay, one last question about, it's not directly related, but just I want to know your perspective. So biodiversity definitely is a big issue, but how do you think about evolution as well? Because we talk about biodiversity, definitely the fisheries, also animals and things are also evolving over time. So if we, for example, if we do not meet climate target, there are possibility that we may not meet climate target. So how do you think about this evolution process? What we measure today, like the biodiversity, we are seeing that we want to keep the current stock like the same species, but they are also evolving to different species, which we don't know maybe. So how to, I mean, definitely this is very complex issue, but how to, I don't know how to think about those issues so that we do not mix up with evolution as well as biodiversity, at the same time.
Yeah. Well, evolution is an interesting topic in that regard. Evolution, when it comes to microorganisms, of course, happens on a fast time scale. When we talk about fish, then it's not such a fast time scale. Why? Because generation periods are a couple of years, and typically the selective pressure is not super high. Typically, I'm saying, because when you look at fishing, then you have, and I come to climate change in a second. When you look at fishing, you have selection, because typically you fish with a mesh fishing net, right? And the small escape and the large ones are retained in the net, so there's a selection gradient. And it selects for fish that grow fast and mature late. And also, selective gradient is strong. I've this shown you before that in the past, in many fisheries, those fishing mortalities have been an order of magnitude of close to 1, meaning that about a third of the fish every year is taken out of the stock and eaten by humans. And that is that needs to be compared with less than a fifth of the stock that is typically dying from natural causes. So typically, fishing pressure is 3 times higher than any natural selection on the fish population. Combined with this selective gradient means that actually we have observed, or there's evidence for quite many fish stocks around the world, that there has been what is called fisheries-induced evolution. And this over a couple of decades fishing with that strong pressure. And it's interesting how one could take this into account when thinking about optimally managing the fisheries. Yeah, this would be a different presentation. I find this fascinating. We have some results, but let's skip this. I wanted to use this example to show that, yes, if you have a very strong pressure, then you have evolution over a couple of decades' time. Climate change is not quite as strong pressure, in particular in a situation where the fish stocks can move, where they can migrate. And that's then usually the solution, and partly also plasticity, but less so a true evolutionary response. That is for the migrating fish stocks. What happens in the tropics, around the equator, where the temperature already now are highest, we don't know. Maybe that some fish species evolve and fill up a niche, but this is, of course, impossible. Well, of course. I see no way to predict this.
Thank you. We've got a second question. Was it here? Please keep it short if possible.
Thank you. Thank you, Professor Kos, for presentations. I'm interested particularly for the second part about the biodiversity in rural topics. That was, I think, in slide 16. What is the definitions of the forest income? Is just, harvesting from income without doing nothing, like without any giving fertilizer or irrigations?
You talked about which income? Sorry.
The definition of the forest income.
That is typically harvesting. Yeah, it's typically timber and harvesting of timber and non-timber products from the forest. Or
Like
in
honey,
particular, also
something like
non-timber products.
Okay. And I'm also interested about the connections about drought and positive effect on forest income. So could you elaborate more?
There is no clear evidence how this comes about, right? This is the evidence that this paper shows. But conjecture is, of course, that the people, instead of working on the field, they go into the forest and work there and harvest there, right? So they substitute they substitute labor from crop growing to the forest income.
Okay, but does it mean the forest income before and after it's higher, right? Just substitutions.
Yeah, well, they have to think about how to allocate labor, right? And then if there's a drought, they allocate relatively more labor to forest income than to crop income. That's what I mean by substitution.
Okay, one very short last question. Thank you.
Yeah, thank you, Professor Martins. Maybe I missed that in your first part of presentation. In one of the expressions you gave about FIX, which is equals to 0.5 multiplied by the number of the neighboring countries. So I'm asking, yes, thank you. So I'm asking about this, the number of neighboring countries. Are you referring to the coastline countries?
Yeah.
Okay. Yes, okay.
Yeah. We looked, and in this case, we simply looked at the number of countries in a given range, and sometimes this included only countries along the same coastline, and in some areas this included also countries on the other side of the sea, right? In particular, if you look at the Mediterranean, then you have both countries to the left and the right along the same coastline, and some countries on the opposite side of the Mediterranean.
Yeah, my question is, what is how do you characterize that? How do you come about this number of neighboring countries? How do you get to know if you're to use the coastline countries or the neighboring countries?
It's simply on the globe. There's we had two specifications. One specification, we simply set a certain radius around the middle point of the exclusive economic zone of the country of interest, and then took all the number of countries in the circle. And another specification, we took a weighted mean of all countries, where the weighting factor depended on the distance to the country of interest.
Okay.
But the results are the same no matter what is the exact definition.
Thank you, Professor Martin Quast. Thank you very much.
Thank you.
Next up is Frieda Burggräfe, visiting researcher at the German Aerospace Center in Stuttgart, and also from the Ruhr University Bochum. And he's going to talk about meeting carbon emission targets and the effects on energy security. So, welcome, Mr. Burggräfe.
So, hello. My name is Frieder Borghofer. I'm working at the German Aerospace Center for the last 7 years, and I'm also affiliated to the University of Bochum. I'm very happy to be here, and I'm very excited to be here because in February 2020 I was here presenting my slides, and 1 or 2 weeks later we as a family went into lockdown. We all were home, and now a couple of weeks ago the school started again. I came out of my lockdown, the house is renovated, and the kids are back to school, and I'm almost hugging the stuff at the airplane because it was my first flight and it was so exciting. While I was in lockdown and not doing much, some things have changed. So last time I ended on a very dark note, and today I can go a little bit further and hopefully show you the light at the end of the tunnel. So the German Aerospace Center is on the one side the German NASA, but it's also a big, huge research institute with 20 locations in Germany, Washington, Brussels, Tokyo, and about 8,000 researchers working there. We look at space, aeronautics, transportation, a lot of e-mobility, and at energy. I myself, I'm an expert in energy system modeling, and I learned from Karen Pittel yesterday that energy system modeling is not good for co-benefit analysis. And she might be right because we are still not going into enough detail there. But I have some slight insights that I can present today, and I can especially give you insights on how the market developed or how the German policy system developed in the last 10 years. So what I do actually is I take a lot of input data, I make a representation of the European electricity system, and I integrate storages, demand-side management, and because we are DLR and have all the satellite data available, we really like geodata and take predicted wind outcomes and solar outcomes and calculate how renewables are going to have their feed in today and in the future. So today I want to talk about 5 things. I want to dive into ancillary benefits theory, but I think all the other experts did better on that, so I just remind you of the main parts that I'm going to refer to. Then we will look at carbon and renewable policies, so that's all the introduction. And then the main themes are, well, what happened from 2010 till 2020, and what is going to happen with regard to co-benefits from 2020 onwards. So we have primary effects, that is global climate mitigations, and we have ancillary benefits, and one thing that was in the literature quite often and that was mentioned here, it often has a local component, and this means our co-benefits. Co-benefits and auxiliary service benefits are always used simultaneously, or sometimes the literature says auxiliary benefits is unintentional benefits and co-benefits is intentional benefits. So with regard to the electricity sector, or in general, there are a lot of benefits you can have from implementing climate policies. We learned about China, and that you can kind of estimate the benefits in the first talk on Monday. We learned today about biodiversity, and I will look more into the economic benefits and co-benefits that we might see. So enhanced energy security, private investments, economic performance, and how the technology change is going to happen. Yes, but there are many more. So when I started in energy system modeling in 2005, we were consulting and making scenarios for policymakers, for the industry, and we also made the scenario for the German Chancellor. And she had a lot of questions with regard to ancillary services, ancillary benefits. She heard about, well, it's creating jobs, so we have to have, she was talking about security of energy supply. She was asking herself, will we reach our energy independency, be less dependent on coal and gas? What about social acceptance? Will this work out? Private investments and improved energy access. So there are so many topics, and she wanted to provide us like the best energy system that is possible with the German Energiewende. And today we will evaluate, because she's going to leave office next month, if she succeeded or not. The DLR provided in 2012 one of these scenarios for Germany. And we were very, and for those of you who are not from Germany, I just want to quickly introduce it. So you see the red part, it's our nuclear power, and it's phasing out by next year. So the last 6 or 7 nuclear power plants are closing down. Then we were expecting the lignite to diminish a little bit until to almost half by 2020, and the coal as well. And it's a little bit substituted by natural gas, and then we will have a lot of renewables coming in. We were not so keen on or not seeing photovoltaic coming, but we were expecting a lot of wind power in Germany. So 2 big policy measures were introduced here in Germany, or worldwide, to cope with the CO2 emissions. On the one side, the carbon trading system, and on the other side, the renewable support. One can't go without the others, so if you just have renewable support and no carbon system, the coal would just produce as much carbon as they would do. But it was supposed to be a good match. What we could see is that the carbon price was quite low, so it was always below 30, and you could see that it was almost a lost decade. So the carbon emissions in the coal sector didn't affect that much. I had one experience when I was at a gas power station, and I was very proud with my simulations, and I asked them, well, I expected 10 years ago that you would run 3,000 hours a year. How good am I? And the man became angry and said, 60 hours. My plant is completely inefficient at the moment. It changed 1 or 2 years later, but I didn't expect this low CO2 price in my simulations. On the other side, we have the renewable support schemes. We had very different support schemes until 2015, and now it's kind of harmonizing towards wind auctions and renewable auctions, capacity auctions. So we could see that the renewable support scheme was working. and we had additional generation from wind and photovoltaics. Until 2015, it was quite a mess, so Europe was trying different support schemes, and then they kind of changed everything. And now auction as a competitive mechanism with a secure component, the feed-in component, and a market price component for efficient dispatch is now the way forward and implemented in most of the countries. As a result, I show you the energy system before Corona came, so in 2019. And on the left side, you see the energy system, and on the right side, you see the renewable part. So in 2019, it was 46% renewable energy. But everything comes with some slight problem. So we had the biomass, and actually the resources, they are limited, so it's not growing anymore, much anymore. We have wind and solar, which are highly volatile, and we need at some point storages to cope with that. We have our nuclear phase out, so this part is gone by next year. We have our lignite and coal exit planned until 2035, but actually 7 gigawatt of capacity is going to leave in the next 3 years. And we had some decline in coal already that we could see, and gas power plants that are supposed to help us overcome the gap between a full renewable system and the current system. So looking at the Corona time, it helped us a little bit in 2020 to reach our renewable targets. So we were for the first time in 2020 above 50% of renewable energy. So now I want to look at 5 categories. And as I said, I want to evaluate the German Energiewende with regard to co-benefits. So the first category was investments. Did we see enough investments in the last decade? And on the right side, you see the investments in renewable energy. You see that we had a big, huge peak in photovoltaics. That was not because there was so much installed, but the things that were installed were extremely expensive. So it was about 200, 300, 400 megawatt euro per megawatt hour compared to a gas power plant of 40 megawatt hours. So it was 10 times. But it kind of paid off. We had a lot of PV coming in. And then you see that the light blue part, the wind onshore, started to pick up from 2012 on, and especially, and I was very happy about that, the wind offshore finally start. We saw finally investments in there. In 2005, I was already predicting wind offshore is going to boom 2 years later, and the reality proved my models wrong. So these were the overall investments in renewables, but the numbers used here are a little bit difficult by the German government. So you have, on the one side, the domestic demand, that is everything that is invested within Germany, and this one was the demand for German companies, including exports. But overall, you could see that Germany is kind of exporting a lot of wind power especially, and importing solar, or used to import solar, so there was a deficit. These numbers come from a study we did for the German government. It's called Economic Indicators of Energy Supply. And just in order to get a rough value, so we see 30 billion euros of investments only in 2011. And overall, the investments in renewable is about 300 billion euros during this 18 years. We see now the green part is the renewable part, so it was quite huge investments, and we didn't see much in conventional. So we saw some gas turbines to be built, but that's pretty much it for security reasons, and some last coal power plants that were built. So overall, we see large investments in renewables, especially investments in solar and PV. Especially PV was way larger than expected. So there's a positive benefit, and we see significant reduction in production and installation costs, and that helped us to become export nations for renewables. We are still waiting for the offshore boom, so we don't see much investments there. It was a little bit delayed. But all in all, yes, there's a positive impact. So now we come to the next topic and look at jobs. And here you see the employment in the renewable energy sector in Germany. Again, it's a little bit difficult to deduct which is like renewable energy, people working in renewable energy and people working for the German market. But all in all, you see that there are quite a lot of jobs in wind. They increased over years. You see jobs in PV, and you see a huge drop in 2012 when all the PV companies in Germany went bankrupt, and the competition with China just became too big. So now you see some PV investments, but it's not so much the German companies, but more the installation of PV. So I was coming back to this report, and I get all this data, and that is pretty much like the German state-of-the-art data with regard to jobs. But the German government and the DLR here provides a very general approach. So we can't really see about what are the regional effects. How much is invested in Bavaria, and how much is invested, how much jobs are created because of windmills in northern Germany, for example. Yes, so yes, there are a lot of jobs. You can kind of think about which technology they are in, but you can't really see the effects. So people who think about if there should be, or politicians, if there should be investments in their region, they don't see these jobs. Yes. And you also, you just see it's very general. So we see when we compare the jobs from renewable energy, like the green and red part, and the jobs from conventional renewables, conventional generation, that by now more than half of the jobs are renewable, and that is quite a good sign. So we can kind of compensate for the current technologies that go out, which are nuclear, and it kind of makes sense. You have a big, huge nuclear plant, or you have thousands of windmills instead, or hundreds of windmills instead. And you need to maintain these windmills, and you have to build them and construct them at so many sites. So yes, the renewable scheme in Germany creates jobs, and it outperforms the conventional generation. However, now primarily nuclear was phased out. So now comes the coal part, and as you all know, that's a very big discussion in Germany, how this can be compensated, and that there are big financial flows. So now it's not a co-benefit, but it's kind of the primary target. What about the CO2 reductions? And actually, with regard to CO2 reductions, our system kind of failed. And I told you about the last decade, and just think of it, Germany makes 1/3, like Germany accounts for 1/3 of Europe's CO2 emission from electricity sector. And our lignite, which emits a lot of CO2 emissions, primarily stays the same, is untouched. So we decrease a little bit of coal. We have almost the same amount of natural gas. So 15 years of Energiewende in Germany, and we still have much higher emissions than everyone else, like much higher emissions in the energy sector than the 3 or 4 next countries after us in Europe. So I gave it a minus. We didn't reach our targets there. We see that it slowly is changing with the increasing CO2 price in 2019, and now with the end of the last CO2 trading phase and with the new CO2 trading phase, we see this spike, and 2 weeks ago, or since 2 weeks, it's over 60 euros per megawatt hour. And now you finally see the change between coal and gas. So the prices there are kind of optimistic that we slowly get where we want to get. So we learned the renewables only have a very small effect on our emissions. We have our nuclear phase out that we reached, but we didn't reach the CO2 emissions. So what about the energy independency? So here we see the share of input energy consumption, and in Germany we're still over 50% of our energy comes from other countries. Only topped by Italy. So here we see in the years between 2005 and 2015, I'm sorry for not having the actual data, we are still highly dependent on natural gas from Russia. On the one side, we are having an increased demand for natural gas because we phased out of black coal or reduced black coal. And on the other side, Norway and Netherlands can't increase their capacities. Actually, Netherlands is currently closing down their capacities, so this part of natural gas is gone, I think, within the next 2 or 3 years, or in the next couple of years. So the dependency on Russia is increasing, and you all know that Nord Stream pipeline just got finished, so the gas providers are already waiting for this new source of gas. Then we go with regard to generation adequacy. That means what about the overall capacity of electricity generation in Europe? And I don't provide a big slide here and want to hold it very brief, but we have a fierce competition actually with regard to generation. So we have overcapacities in Europe, and because this is one reason, and the second reason is the low CO2 price. So we saw in the last decade that newly opened gas power stations were closed down and became backup power plants because of this overcapacity. With regard to short-term security of supply, here you see that the increased wind energy also leads to increasing cost for system management. So we have a lot of fluctuation, and because the market design is not very efficient, this fluctuation, we have to pay for this kind of uncertainty. And the payments were quite small in 2013. That was kind of midway through my life in the energy market. And everybody was thinking, oh, that's good. But then within 2 years, it's five-folded. So the costs went up significantly because you had so much wind energy in the system that suddenly the fluctuation just became very prominent. But as I said, the market design is one part, and if you increase the market design, you might increase the short-term security of supply and reduce the cost here. So there's potential for optimization. The other thing with regard to ancillary benefits is in short-term security of supply, in order to balance our system, we needed capacity, transportation capacity to transport our electricity from northern Germany to southern Germany and from southern Germany to France and other countries. So we had huge investments in the electricity grid, and therefore it didn't provide us with much security of supply, short-term security of supply, and we had a lot to invest in order to keep our security of supply to a certain level. The last one is the regional distribution. As I said, in 2016, we introduced renewable auctions. In the beginning, the renewable auctions worked quite well. We had a tendered capacity, and we had the bids, and we had a lot more people bidding than the tendered capacity. So we had competition, prices decreased, and everything seemed to be fine. But then the market design were changed again from November 17 to February 18. And electricity companies had to provide the electricity companies had to be very far in their process with regard to social acceptance of the wind power station. Therefore, it became much harder, much more costful. And you see that in the last few years, the tendered capacity and the bid into the market didn't even match. Another big problem was seen here. One state in Germany, Bavaria, introduced a 10-ha rule. So here you see white parts are the potential wind sites you can have in Germany when you can have 120 meters between the windmill and the next house. Maybe that's a little bit over-optimistic, but with regard to noise, 600 meters, 400 meters is a good number, and then you have huge potential. But Germany is very densely populated, so if you introduce a 10-ha regel, you end up with 2,000 meters, 2 kilometers different distance to the next building. And we could see that within southern Germany, there's pretty much no potential for future windmills. So with regard to locations, we had a very nice study that we did. We took all the geodata information, we modeled the renewable auctions together with the RWTH Aachen. They looked at how much investments will take place, and we took it back into our energy system. We concluded in 2020, on my last presentation here, that we are currently on the left top corner. And it's not so bad. We see some slight investments in the south of Germany, but because of not enough competition in the market. So they were just taking every windmill that was possible. But that was not optimal, and you want more competition, but with more competition and the national auction, you will end up in the top right corner, which means you will have no investments in the south of Germany, but at the same time you have most of the electricity demand in the south of Germany because it's like the industrial area. So actually where we want to come is down here on the right corner where we have investments in south of Germany. So we propose the southern, northern state, like different auction scheme that prefers or wants to see a certain amount of capacity in southern Germany. And then I went into lockdown. So the incentives for regional distribution were not so good. We saw that, we were foreseeing a lot of investments in north of Germany as we saw in the past. And that was the result, or the final result for my look at the time till 2020. So just recapitulating investments, we saw large investments, we saw jobs generated to a large extent. However, we saw also certain gaps, and certain decisive moments where PV went out of the market and a lot of people lost their jobs there. We see a flaw in the ETS system and a nation that prefers the nuclear phase out over helping the world by phasing out their CO2 emissions. We see that with regard to energy independency, which was a primary goal of Angela Merkel with the Energiewende, that was not reached yet. We saw large renewable investments and overcapacity, so we had kind of generation adequacy, so there was competition. And we saw, with regard to short-term security of supply, that huge investments had to be taken. And we saw that the incentives for the renewables were not sufficient. So, all in all, in 2020, when I left here, the outlook for the energy system was grim. The co-benefits, they were not a strong argument on the regional level for investing in renewables, for saying, well, my region has to be the one who's first in renewable investments and first in climate change and reducing CO2 emissions. There was a lot of discussion on the European side with regard to health benefits, but on the local level, you don't have an understanding of health benefits and how much lives are saved and how it feels to have 2 more years of lifetime. We had a lot of adverse side effects instead in Germany. We had a lot of environmental protests. Now there are windmills in my garden. There are a lot of protests against the power lines that we need for energy security. And we had not enough incentives for the carbon market, a lot of inefficiency, and no wind investments in south of Germany. And we had a lack of social acceptance. You could see it actually in the political discussion of the last few weeks when Habeck on the right side from the Green Party and Markus Söder from the Black Party, which he is in the, Markus Söder is in the south in Bavaria, they were discussing, and he was saying, well, in the north we have so much renewables and we did everything we could and you didn't. And it's something that people in Germany feel. So renewables, it costs, they are there, you have to see them. And in general, people, what you learn from research is people have a strong feeling of justice. Yes? So I don't have a problem with a lot of windmills if my neighbor has them too, and if the people in the north have them too. Okay? So there's a strong notion of justice, and at the moment it seems kind of unjust. So we have this renewable scheme until 2020, and then in 2021, it was slightly changed. Most of the things stayed the same. It still stayed a combinatorial auction. The period of funding is still 20 years, and the remuneration scheme is pretty much the same. There were 3 things added. There was the regional auction for south of Germany, so 15 to 20% of renewables will be awarded to the south of Germany. The targets were significantly increased for wind energy, and there were additional incentives for communities up to 0.2 cents per kilowatt, which is not much. But this new share of 20% from the south of Germany and this €2 per megawatt hour for local communities, that is, if you, for like a windmill, for every windmill, the local community gets between 13,000 euros in south of Germany and 30,000 euros at very good wind locations in the north of Germany. That's an incentive, and it's a regional incentive. And we have the new Green Deal that made it all made the goals even tighter. But this incentive, and I heard about them. I didn't have it in the slides for many for previous talks, but when I was listening here to all the wonderful talks that I heard in the last few days, I realized it is important, and it is changing something. It's changing the narrative, because suddenly it's not, oh, the people in the south are not doing anything, that's bad, but oh no, they are too slow in the south, and we have a lot of possibilities to have wind farms in the north, and we have a lot of free land and good wind location, and we get 30,000 and they only get 13,000. So yes, let's do it. Let's find new places and invest here. So from my point of view, there's a different narrative. There's some kind of competition, and you understand what is happening. So it's not about you kind of internalize the co-benefits. Yes, you have monetary co-benefit for your region, for you people, for your neighbors and yourself. Better schools, whatever. So that is a good incentive. And when you see the amount, if I calculated correctly by the rule of thumb, in 2050 would be maybe 100 million euros for Baden-Württemberg and up to 400 million euros for all of Germany. So we made an outlook for the state of Baden-Württemberg where I live. And when we did it in 2017, we were telling them there's a lot of wind onshore to come, and yes, you will have a lot more imports, so you can't supply yourself. You are dependent on northern Germany, you are dependent on France, you are dependent on Switzerland to fill your demand. But the wind over time is going to help you. In 2020, I was thinking, well, that will not work, and the energy system in Baden-Württemberg is kind of going to crash, or there will be no much energy security there. Now I know that at least some wind is coming to the south of Germany, but still in 2020 we see it will be a strong electricity importer. We also see, which we did not do, if you remind our last analysis from 2012 for Germany, we were always thinking about electricity demand is going to decrease. Now we know, no, we have electric vehicles, we have electrolyzers for hydrogen production, electric heating in industry. So no, we need a lot of more energy, especially in highly industrialized areas. So it's still a really, really hard task for a state like Baden-Württemberg to keep the energy system running. It's really, really hard. But I think it could be possible now. So I'm almost done. We saw the left side already, and now we are on the right side. So where are we going from 2020 till 2050? Currently, the auction design still leads to underinvestment, but we saw it now provides better incentives. With regard to jobs, we did quite well in the past, but the competition with other countries is becoming larger. We see it in the wind industry. As soon as the demand in a certain region is high enough, the production shifts from Germany to this region to produce the windmills there. So with regard to CO2 reduction, well, the next decade it's going to work, and we will kind of halve our CO2 emissions by 2030, but we are coming from an extremely high level, and we slept for 10 years. With regard to energy independency, we see a high shares of production from renewable, and because of this introduced new capacities, we have a lot of competition, and this will prevail in the next few years. With regard to short-term energy supply, we have to have a very large demand for flexibility. The rule of thumb scientists found kind of, or I found in a paper with a lot of very knowledgeable scientists, was if you reach 70% of renewables in your electricity system, suddenly the electricity system changes completely, and you need a lot of storages. So now you can come by, and no one needs to store air pressure or something, and we can come by increasing the power lines to Norway, to Switzerland, and just using Norway and Switzerland as a huge storage. But if you have 70% of electricity, this will not work. So there's new market design required, but also a lot of new investments. And with regard to regional distribution, it's important to introduce more regional incentives in energy and climate change. I think it's something I learned in the last 5 days, but I think it's something I take with me for the next few years. I think as long as climate change is something globally, it's very difficult for me. But as soon as I have, in my region, have a very tight target, as soon as I know my driving with my car will be measured and my region is not doing so good if it gets worse numbers if I drive too much, then I will think about it and I will look at my hood, look at my neighbors and say, well, yeah, we can do it. Let's do it now. So we need really tight targets for each region and a new policy design here. Thank you very much.
Thank you very much. We've got time for a few questions. I see 1, 2, right?
So I'm just going to touch the third rail because I've been living in Germany for a year and I haven't understood this yet. Can you, when you mentioned the nuclear phase out, you basically described it as a choice to get rid of nuclear power at the expense of CO2 emission reductions for the world at large. Is there anything in the energy strategy that justifies this phase out of nuclear energy? I mean, I know that this is something that lots of people are thinking about in different ways and it's not entirely clear, but is this being done because there's just a dislike of nuclear energy, or is this being done because sort of maybe German energy policymakers have a different view of the long-term risks? Maybe they have higher views of the chances of nuclear meltdowns than people who are working on this seriously in other places of the world. Can you just walk me through basically why we're doing this?
Okay. In 2006, there was the Angela Merkel introduced an Energiegipfel, and she and the industry discussed how to reach the climate targets and how to get there. And first, because the Green Party was in power, before that, they kind of introduced an end to nuclear. So Germany was always very afraid of nuclear incidents. But then they started to discuss and said, well, we need more nuclear energy, or need it longer. And we made wonderful studies prolonging the nuclear energy in order to reach the climate targets. But then came Fukushima, and within a few weeks, 3 nuclear plants were shut off, or 4, which were quite old. And there was a clear pathway, and it was shorter than before, that had the nuclear phase out. Actually, I had a HIVI, one calculating everything. So Angela Merkel was praised by so many people. Oh, finally, she did not go with the industry. She managed to step on the brake and phase out nuclear earlier. But actually, there was not much pain for the energy industry. So the nuclear phase out is something that was kind of written in law in 2000 or 2001, and they just proceeded on it. But the problem was the CO2 price. So we built a lot of gas power stations and didn't use it, and instead we used a lot of coal all the time. Yes.
Okay. Thank you. Second question.
Thank you for your presentation. I would like to know some more details about the spatiotemporal resolution of your model. As I know, it's a remix model. As I guess, it has an average resolution, temporal resolution. I would like to know about the computational tractability of your model and how much regions how much, I want to know how much details in grid, node, or, the connections between those nodes you have defined in your model.
So we like to work with a lot of tempo in time series, like from wind and PV and so on. So our temporal resolution is 1 hour, 8,760 hours per year, but we are only looking at every 5 years. And then we have the investment till 2050. The model used to be very rough, so we had 6 to 8 regions for Germany, and then 60 more regions for the surrounding European countries. Now we work a lot with high-performance computing, and we have some models that try to model like every node, like the electricity grid within Germany and France, up to the high voltage lines. So we have all the different nodes of the high voltage lines. And then we have different aggregation methods. So for some studies, we use the different states within Germany, and for some studies, we more look at a higher aggregation, like a mixture of NUTS 2 or NUTS 3 perspective.
My second question is about the considering the sector coupling. Is it possible to consider, for example, to link transportation sector? If you want to have an electrified transport system, is it possible to see the challenges and opportunities that those kind of sector coupling can bring, or even linkage between residential sector and power sector? And totally, I want to know that how do you model demand side? Is it just an exogenous, modeling, or you're disaggregate different types of demand in your model? Thank you.
Yeah, we have different types of demand modeled, and we have certain possibilities of demand-side management. I think it's about 30 technologies representing the whole industry and GHG sector. We have also households, and with regard to electricity, we have a simplified version of the batteries of the cars, and then we can decide if we integrate them and they can store electricity and provide it back to the grid, or we just take them as electricity demand, or we have some temporal shifting of loading cycles. We work closely together with other areas of DLR, which have a very good representation of the car demand and the future structure of electric and hydrogen cars.
Thank you very much. One last question. Maybe it depends on how long it is.
Thank you for the nice presentation. I actually have a question regarding the incentives that were given in Germany for the wind turbines, that they were €2 per megawatt hours. And you said that that's a regional incentive. So I wanted to like more how these are being given to the region. That's one thing. And if these are onshore turbines, and if what do you think, or in general, if the ongoing discussions involve the offshore wind and specifically the floating offshore wind, and how would that be affecting the incentives that are given at the moment, at least?
Okay. So the regional incentives, well, on the one side, you have an auction that tells you need a certain amount of wind in southern Germany. So in general, the auction results for wind power station on solar in southern Germany is higher. Then you have a regional component, like something the owner of the wind farm can pay to the local government, which I showed, which is not so big yet, but it's a first incentive to help and work together with, to facilitate the work between the local government and the owners of the wind power stations. And the last question was? Offshore wind.
The offshore wind, and specifically the floating offshore wind, because that wouldn't be affecting any harbors or so.
I didn't look so much at offshore wind, so it's other people that do it. So I think we are not distinguishing at the moment between floating windmills and not. But of course you would have additional potential in the North Sea, because at the moment pretty much all the regions that are viable are already written out for offshore installations, and this will provide new opportunities. And I think offshore is going to increase. We always said like 15 years ago, offshore installations will be almost half of the onshore installations. And this is quite a long way to go, because we have so much onshore wind installations by now.
And the incentives you would be expecting, like that could be like the wind farm owners, the offshore ones, that would be less than those for the onshore?
They are less, but you have a lot. Now, at the moment, I don't know. I think they are higher, but you harvest a lot more wind offshore. So what was important is that you have the connections and that you don't have to pay for the connections. They are there and they're guaranteed. And now that they overcame certain problems with regard to that the windmills didn't last so long because of the salt of the water, I think there will be a boom offshore quite soon. Or you see it already in Great Britain, and we are just following.
Thank you very much.
Thank you.
It's the coffee break now, so if you have any more questions, maybe you can find them there. We meet again at 11:30 here. Thank you.
ist denn Herr Meier? Weil der hat die neueste Präsentation, ist die schon drauf? Ach so. Das wäre nur ganz gut, weil wir anfangen wollten, oder? Aber es ist neu, oder?
Genau, die Sie mir gerade
geschickt
geschickt haben.
Sicher, wo die steckt.
Okay, everybody, welcome back from a coffee break. Professor Dr. Dirk Rübbelke from TU Bergakademie Freiberg here is up next, and he's going to talk about international climate transfers and ancillary benefits. So, thank you very much. Welcome.
Thank you. Thank you.
Yeah, the presentation is about international climate transfers, and in fact, technically, the approach is in that way that we take a look at ways to transfer money from the developed to the developing country that induces the highest level of mitigation. So the primary objective here indeed is mitigation. But the transfers are provided in an environment where there's an occurrence of co-benefits or co-effects. And here you have to observe some conflicts and trade-offs, which we, in a paper which I present here, seek to address. Yeah? And in principle, a major challenge is not to blur too much, to water the main objective. Yeah? And there are different schemes from which we can learn for future schemes. Yeah? The scene for international transfers is in principle set by two major international documents: the agreement, the Paris Agreement, and the 2030 Agenda for Sustainable Development. We have talked about this recurrently at this school. And you also recurrently saw this depiction of the different sustainable development goals. Yeah? They're not weighted, yeah? So they're here equally. We have no primary objective in climate protection. Yeah? I see this point, yeah? And this has, of course, to be taken into account. What I do, nevertheless, is I focus more on the Paris Agreement, which has a primary objective. And there's also secondary objectives, which can be assigned to the other goals here. Yeah? I will come back to this point in a second. Yeah? So in principle, what I do is when I talk about the primary objective, it is mitigation. And if I talk about sustainable development, sustainable development takes the role of a co-benefit. And sustainable development would be everything here except for climate protection. So that I can make a distinction between one objective, which is our primary objective, according to the Paris Agreement, and the other co-effects. Yeah? And what I would like to do is to see how can we pursue the primary objective. Yeah? So I have
implicitly some weighing in here, which is not so uncommon, as I will explain. There are international schemes which have the same approach, yeah? As international transfer schemes. Okay. Paris Agreement, yeah. So we have a link in the Sustainable 2030 Agenda for Sustainable Development to climate, but we also have a link in the Paris Agreement to sustainable development. Yeah, and this is very prominent in the Article 2 of this agreement. Yeah? So the goals should be pursued in the context of sustainable development. You can find such references also in other parts of this agreement, and again, in a second, I will come to another important part of this agreement, which is in particular important for international transfers. Okay, what we can now keep in mind, they're closely related, both documents, with a different weighing of the different goals. And now, as I said, I will look at transfers which seek to address, of course, climate mitigation, but also taking into account the co-effects, yeah, the sustainable development co-effects. We have, in a way, a dual objective here, which becomes very obvious when we take a look at Article 6, which establishes international cooperative mechanisms, yeah, like the successor of the CDM. This article is quite fiercely discussed, yeah, so it's not fully settled, and this is a point where there's a lot of dispute. So it's quite interesting to address this, I think, here. Okay, and yeah, as I said, we consider sustainable development effects as co-effects, except for the effects in the context of mitigation. Arranging the different objectives, yeah, can be assigned to different, there can be two different general perspectives applied, which I will present here in this presentation in the first part. Yeah? And by taking these two perspectives, I will better explain the research questions which I would like to address. Then in the second part, I will present shortly the research approach. And thereafter, I go to the application, yeah? To two different schemes which we could which were applied in the past and from which we can learn something for future mechanisms. My focus is here on the question, to which extent can they efficiently provide additional mitigation? Yeah? I will then expand the evaluation by also taking into account a broader perspective on efficiency, and will also include other evaluation criteria. It remains all a bit narrow, I have to admit, yeah? So justice and such effects or perspectives aspects are not included here. Of course, they should be taken into account. Yeah, finally, I provide a discussion. Okay, let's turn to the two different perspectives. Yeah, there's a saying, killing two birds with one stone. It's frequently traced back to Thomas Hobbes. I think it's not so clear whether it's fully true that it's from him. There's this reference, indeed. He says this. Probably he was not the first. Anyway. So what you can do then is, from this perspective, you implement climate policies or transfer schemes and try to solve more than one problem simultaneously. Yeah? You do not only induce more mitigation, but additionally you address other sustainable development goals. Yeah? And of course, it's attractive for policymakers to create such all-rounders. Yeah? You address more than one stakeholder. Yeah? However, this could, of course, be at the expense of reaching one goal. Yeah, and okay, first perspective. The second perspective is from a Nobel laureate, Jan Tinbergen, who formulated the Tinbergen rule. It states more or less that you, in order to reach a target, you need at least one instrument, yeah, to reach the objectives efficiently. If you have less instruments than targets, inefficiency will impend. So the possibility of killing two birds with one stone would here be considered with skepticism. Yeah, so these are the two perspectives. Yeah, one perspective, take one policy and solve more than one problem, and the other efficiency perspective from Tinbergen stating, well, you should have more than one one instrument in this case. You should not use one instrument and have the impression that you can solve more than one problem with it. Okay, now from this we derive two key research objectives. We first examine how international transfer mechanisms addressed multiple effects in the past, and we want to learn from this. Yeah? How did they support mitigation? As I said before, this is the main focus here. Yeah? And these mechanisms, although some of them focused on global benefits, so on mitigation, also took into account co-effects. Yeah, I will explain. We are here now in a field which was suggested at the Paris conference. In Paris, it was said we should learn from past mechanisms for future transfer schemes. Yeah? So schemes under Article 6 should learn from the past. Yeah? There's this decision from Paris concerning this. And the second research question is deduced from Tinbergen's warning. We explore whether the rise in co-effects of a mechanism is desirable throughout. So is it really that it's desirable to kill two birds with one stone throughout? Yeah, and we pay attention to cost effectiveness only in the first step concerning mitigation. Yeah? As I said, we will then thereafter broaden the perspective a bit. Yeah? Okay, let's turn now to the two schemes which I will consider here. First one is the Global Environment Facility Trust Fund, which is not frequently done, I have to admit. I don't know whether it has been done at all in the context of the Paris Agreement. And the second one is the CDM, yeah, where you can find a lot of literature already, referring also to Article 6. It's a bit challenging because one is a more market scheme and the other one is disbursement by an international fund. So that to some extent here we have some stylized examples. So I do, for example, not consider the demand side of the CDM, yeah, but take some preconditions which I first derived in the context of the JES scheme here. I do this by applying a graphical method. Yeah? So no calculations, no math here, just an illustration by a graphical method which has been suggested by David Pierce and which in principle is very similar to the discussion or the graphical discussion of cohesion bargaining. So again, cost effectiveness is here in the focus, meaning here we want to reach the maximum level of climate protection with a limited amount of funds. And when I talk about the methods, I now turn very much to the beginning. Yeah? are not all economists, but those of you who are had a microeconomic course. Yeah, and you have these nice objective functions, utility function, and you say, well, we purchase 1 or 2 goods, yeah, or 3 goods, and they're homogeneous. Yeah. So, of course, some of the students ask, why is it homogeneous? If I buy a car, yeah, and you put this good in the utility function, it could be a red car, it could be a fast car. Yeah, it's not very homogeneous. So an idea could be to take a quite homogeneous good, like an egg. Yeah? But there's then been an older article. Yeah? It was published already, or it was written in the 60s of the last century. It was then only published quite late in 1980 because it was very influential. There was a paper stating, well, even eggs are not homogeneous. Yeah? You have different kinds of eggs. And even if you have chicken eggs, there could be white ones, blue, not blue, I don't know whether they're blue ones, but brown ones. And you have organic eggs. So, and we pay different prices for these eggs. Yeah? Organic eggs, we pay a higher price than for non-organic eggs, for example. Yeah? So, and on every egg we can find now a code. You know what the code says? Yeah, now you know it's written there, I know. But have you ever thought about this? Yeah? What does the code say? Now, next time when you purchase eggs, you will think of this presentation, I hope. Yeah? Okay, the stamp says the method, it expresses the method by which this egg was produced. Yeah? For example, in this case, the 0 stands for organic egg. Yeah? And there's a country code, DE, for Germany. And then I think the 03, yes, it's for the country in Germany. So as for example, Saxony, or in this case, it's Lower Saxony. Yeah? 03 is Lower Saxony, and you have an identification number of the farm. Which is important because some people would like to purchase eggs which are from nearby, so that there's no, there are no emissions from transport, for example. Yeah? Or they want to support their local community. And there's another distinction of eggs. You have classes of eggs. Yeah? One class, they're consumable eggs, and the other ones, they're used for production of other foods. Yeah? So even these quite homogeneous goods are heterogeneous, and we are interested in the characteristics. Yeah? And here we are in the new household theory, which is not so new anymore. Yeah? It was largely influenced by the characteristics approach by Kevin Lancaster, yeah, in the last century. What he says, we are not interested in goods, we are interested in the characteristics. Yeah? Whether it's organic, whether the taste is well, and so on. And this brings about a utility. We have a two-stage affair between goods and people. And this is in principle the structure which we use here in climate policy. You're not interested in a project, you're interested in the consequences. And the consequences are not only mitigation, there could be other effects or characteristics. And here we are in now this school. We are back in this school. We have several effects. We have several effects on sustainability, and the relevant aspects should be taken into account. That's what the theory says here. Okay, and here we are, I can here be quite fast because Wolfgang Buchholz yesterday explained it already. There is this inter-public good approach for goods which have different characteristics, and some of the characteristics are global or public, globally public, and others may be more local or more private. Yeah. And in this case, if you have different degrees of publicness, you have an impure public good. Yeah? And yes, the mass we had already yesterday. So here it will, I will not return to the models by Korns and Tendler, but of course I have to mention them. They have really developed a lot on this model, and it has been further developed in the context of environmental economics. I think there are papers considering also that the characteristics of climate policy, like mitigation or co-benefit, can be produced by different technologies. Yeah? It's not only applied to climate. Most of you know what Matthew Cochin, I guess, yeah, working a lot on green goods. Yeah? And what is also very familiar is, of course, the literature on warm glow giving. Yeah? If you, Andreoni, very famous papers in 1989 and the beginning of the 90s, also doing a lot of experimental stuff on this. Yeah? Yeah, and this is now applied here to climate policy. And the first scheme where I would like to apply it is the Global Environment Facility, where money was taken from the industrialized world and channeled to the developing world. Yeah? Incremental activities are funded here. These are activities which would not have occurred without the support of the GEF. Yeah? So we have a baseline, or meanwhile they've changed the wording. They say the business as usual. And yeah, if you provide something beyond, this is incremental. And interesting point is that the GEF, the Global Environment Facility, had the same perspective that I took here initially in this presentation. Yeah? They had a pure global benefit orientation. They were only interested in mitigation. They didn't care about gender or something like that, effectively. Yeah? So the money was not given to help poor people to become less poor. It did not, was not the intention to secure water sources. The main intention was global benefit orientation, to give money which should bring about projects that help all. Yeah, but you see that the funding is limited. Yeah? So you should think about wisely spending money. We have a really challenging problem which threatens our planet. And in order to secure our survival, we have to efficiently use these funds. Of course, they're not the only fund. Yeah, I'm pretty aware of this. But things become more severe when you see climate protection is only one focal area of the GEF. Yeah? So the money is not only spent on climate protection, there are also other areas. Yeah? These areas change. Yeah? The same as the funding changes, the amount of funding changes. Also, there were different focal areas in the past. At the moment, it's these 5 areas. Well, and now let's turn to this characteristics approach to this X. Yeah? So we have not an X, we have a climate policy. And it brings about, in the first stage, effects or characteristics. Yeah? As I said in my presentation, this is the primary aim. According to the Paris Agreement, you could also argue this way, but for sure you can say, from the point of view of the Global Environment Facility, this was the main intention. Yeah? We had global benefit orientation. We wanted to protect the climate. But of course, there are also co-benefits, co-effects. Yeah? So further characteristics, yeah, which could, of course, differ from project to project. Yeah? And we have the primary benefits and the co-benefits, or sometimes co-cost. Yeah? So again, first stage, second stage. Other effects, co-effects, I would like to mention here, clean water availability. So I can refer to the Sustainable Development Goal. What we, I advertise here books. In fact, in 2000, there was an influential study by the OECD on ancillary benefits. And 20 years after that, we wanted to take stock of the research. What has happened? Where are new developments? What has been reached? Yeah, and so last year we published this book on ancillary benefits and including such aspects. Yeah, and yes, Spiros is also here. Your husband is included there, and so many of the researchers which have been here participated in this book. And as I mentioned before, and as Wolfgang Buchholz mentioned yesterday, we have primary benefits, which are global public goods. So he said climate change is global public bad. I could also say protecting the climate is global public good. Ancillary benefits were frequently, there was a focus on local air pollution as a co-benefit. Yeah? So the idea arose that these ancillary benefits are mainly local, so they are private from the host country of the project. Which to some extent is true, but as we learned this morning, biodiversity could also be a co-benefit, which is not necessarily to be considered as a private good from the host country. It could also be considered as a global public good because it preserves genetic pools from which the whole planet could benefit. Yeah? So that's not fully clear whether co-benefits are always private. Yeah? But there are, of course, co-benefits, local co-benefits, which are private and which are highly relevant. Now let me turn to the JEF. How did they deal with their global benefit orientation? Then also the objective to act cost effectively. So generate as much global benefit as they could do with the limited funds. They discussed two different schemes in the 1990s when the JEF was established as a financial mechanism of the UNFCCC, and one was the gross incremental cost. That meant if you induce an incremental activity, an additional project in a developing world, you pay this country the full amount of cost. Yeah? So they have not to pay anything. They have not to contribute to this finance. The alternative was net incremental cost. So you net out the co-benefits, which are the local co-benefits. Yeah? So if you, for example, have beneficial employment effects in this host country, developing country, the host country also has to contribute to some of this funding. Yeah? Effectively, finally, they had a mixture of both schemes. Yeah? And well, but let me illustrate now these polar cases. Let's consider here a developing country with marginal abatement cost. Yeah. Yeah. In this stylus example, just linear function, marginal abatement cost of greenhouse gas emissions. And this developing country has a marginal benefit, of course, from its activity to protect the climate. Yeah. These are the benefits to the host country of the project, which it derives from the public effect of climate change mitigation. Because it's a public good, of course, other countries also benefit from it, and so we also have here the global primary marginal benefit curve. Sorry, it's a bit difficult here with this. Up there, yeah, which includes now all benefits from climate protection in this host country for the whole world. Yeah? It's a public good. Okay, here we do not have any co-benefits yet included. Yeah? In this setting, it would be efficient from the developing country to abate up to this level. It could be interpreted as a baseline or business as usual. And of course, the JEF would like to bring the level up to the efficient amount, yeah? Which would be the intersection of marginal abatement cost curve and the global primary marginal benefit curve. Yeah? Okay, that's quite easy, yeah, standard setting. But if you now include co-benefits, which is frequently done in a way that you offset the cost of abatement by these benefits, yeah, so that you have net abatement cost, yeah, then you have a different efficient outcome. Yeah. You can also, I mean, this kind of depiction, have been two influential papers in 1996 by Paul Ekins on inventing this structure of including the marginal abatement, marginal ancillary benefits. Yeah? Okay. Here you see then, yeah, if you consider the net cost, you see that there are co-effects on a local level. It would be efficient from the developing country to abate up to this level. So this would then be the business as usual. And Jeff would now would like to bring about an even higher level of abatement because there are now these additional costs. So the first research question is referring a bit to jump a bit. The first research question which I mentioned in the opening of the school was on are there opportunities from co-benefits? Yeah? And of course there are, because you see, if you include them, yeah, of course, efficient abatement levels will be higher. There is more incentive to abate. Yeah? And we stick now with these efficient levels. Yeah? So now we have a situation, this is what the country would have done anyway, and Jeff would like to bring about a higher level. Yeah? Suboptimal lower the protection. And how can we do it? Of course, we can fund it. And as I said before, we can do it by two different schemes. And in both schemes, yeah, the developing country will get additional benefits because of the slowed global warming. Yeah? This is a benefit it gets for free in any of the JEF schemes. Yeah? This is not taken away. The dispute is not about these benefits, which are free of charge for this developing country. The others also benefit from climate protection. Yeah. The dispute is about the co-benefits. Should we leave them to the developing country or should we take them away? Yeah. We have here the first scheme, which is the net incremental cost scheme. Here you just reimburse the net cost of this project, so you net out the co-benefits. The gross incremental cost would, of course, be higher. And quite obviously, cost effectiveness would say we should disperse only the net incremental cost. Yeah? That was the perspective of many economists. Yeah? It was argumentation that a clear rule, low benefit orientation, cost effectiveness, it's clear you should stick with a net incremental cost method. Later on, when I invent additional criteria, you will realize that the perspective has changed. Yeah? For several reasons, practical reasons, transaction cost reasons. Yeah? But these are now the two polar cases, and what you can say now in a very trivial way, most cost effective is a NIC scheme. Yeah? Not very surprising. Okay, I come back to the scheme, down only the basic structure, and I would like to compare it to a scheme which is now proposed under the Paris Agreement, which is frequently called Sustainable Development Mechanism, and not Clean Development Mechanism. Clean Development Mechanism, I think most of you know this. Developed countries can invest in mitigation in developing countries. And by this, they purchase certificates. Yeah? They can use these certificates to offset their own obligations in their home country. Yeah? So instead of abating in Germany, you could go to a developing country and invest there. It's cheaper, maybe, yeah, and then you get the reduction accounted for in your country. Okay, and the CDM had a twin goal. They wanted, of course, to development benefit to the host country. So quite different to the JEF, they claimed a dual objective of course, mitigation and local sustainable development. The problem was that the developing countries frequently had such a high incentive to attract investments that they set a quite low limit to the requirements. So local sustainable development was not really a major issue. Yeah? In response to that, there was the establishment of premium schemes, yeah, where they had certificates for projects which had a higher level of local co-benefit. The certification was expensive. The projects tended to be more expensive. So these premium markets remained a niche. Yeah? But now you could, if they now call the new schemes or one of the new schemes under the Article 6 Sustainable Development Mechanism. And sustainable development is frequently stated in the Paris Agreement. Yeah? It could be reasonable to say, well, we generate a scheme where you are obligated, where it's mandatory to have higher sustainable development effects. Yeah? So in principle, you make such gold standards or premium standards mandatory. Yeah? So that the dual objective is more now taking a look at the co-effects. Yeah? Co-effects get a higher weight. Okay, let's now see, again in a very simple setting, what effect this would have. Yeah? And I'm pretty aware that it's a very narrow investigation. Yeah? But I would like to make one point, yeah, which I think is worth discussing. Okay, we assume now that in the future scheme, not the CDM anymore, but the Sustainable Development Mechanism, or not clear how it will be called, that this mechanism requires a minimum amount of sustainable development, which is higher than in the older scheme. We assume, in order to keep things comparable, we do not model every actor. It's quite generalized, this concept here. The marginal abatement costs are to be paid by the investors to get the certificates, and the marginal abatement costs are assumed to be higher than in the former schemes, yeah? Because you require now a higher level of sustainable development. And we assume that, like in the JEF scheme, this mechanism will bring about the desired outcome. I would like to make it comparable. Yeah? So I stay with the same challenge to increase the abatement. But we have to be careful in this respect for two reasons. First, this is a market mechanism. We do not know whether there's a demand for these certificates. Yeah? The second thing is the abatement level is the same, should be the same in both depictions. But the projects which are employed are different, because here we observe projects which are only eligible under this scheme. These are projects with a higher minimum requirement of local sustainable development, which then, of course, should be proved by such certification company like that established the gold standard. Yeah, but there are also other standards, could also be in other agencies. Yeah? Okay. So we are aware already of this depiction, but what we now have is we have other projects with a higher marginal abatement cost level. Okay. Now you could, of course, say, well, if the marginal abatement cost curve changes. Why does this curve not change? Yeah, you also have marginal abatement cost included. The reason is quite simple. It could change. It's not necessarily the case. It's most likely that it will change, but we do not know how it will change. So it could be that the increase in the marginal abatement cost induced by a change of the projects is of the same amount as the change in marginal abatement benefits, marginal ancillary benefits, sorry. In this case, this curve would not change. Yeah? But I will display in a second further possibilities. What we anyway see in this moment, if we have, of course, more costly projects and the marginal abatement costs are paid by the investors, yeah, this will increase the cost. Yeah? If we compare to this, in our stylized example, to the JEF scheme, this would, of course, because of the additional requirements of concerning sustainable development, bring about the highest cost from the payers of transfers. Yeah? So cost effectiveness with respect to raising mitigation is lowest in this scheme. But now let's return to this curve. Here, if it stays as it is, the marginal abatement cost changes in the same way as the marginal abatement cost, marginal ancillary benefit cost, marginal ancillary benefits change. But it could be that these projects bring about more ancillary benefits than they cost additionally. That would be good. Yeah? Because then we could expand the concept of cost efficiency and also look whether this change in the scheme brings about an efficient provision of co-effects. And here it is the case that the increase in marginal abatement cost is associated with a stronger increase in the marginal ancillary benefits. Yeah? So we have here some efficiency gain. Yeah? We have an increase in mitigation, but we also have an efficient increase in marginal ancillary benefits. But this is not necessarily the case. It could also be that the cost increase stronger than the additional benefits increase. Then we would also have an inefficient provision of ancillary benefits, which of course would not be desirable. Okay, so we cannot be sure. And we know that it's more costly for the investors, this scheme, than the other scheme, but the scheme in any case is attractive for the host. Yeah? The host will get additional ancillary benefits, regardless of whether they are produced efficiently or inefficiently, regardless of whether the ancillary benefit increase is higher than the cost increase. Yeah? Because the costs are paid by the international investors. Yeah? Okay. This is nice to see in this simple setting what is desirable and not. But I have some contact with the director of the evaluation office of the JEF. He was there some years ago. He was the person who said, well, we skip the evaluation of co-effects. I asked him, why did you do that? Yeah? And he said, well, shock, why did you do that? He said it was very costly. The transaction cost of assessing co-effects were partly prohibitively high. You have small projects and you have to evaluate it, and the consultancies earned a lot of money from this. So he said, we changed it. We said, well, instead of using incremental cost methods or based on this concept, we invented incremental reasoning. Does anybody know of you what incremental reasoning means? Okay. Sorry that I have to laugh, but because I think it's not very clear what it is. But it's applied, yeah? In principle, what you do is you meet, the agency meets agents which want to implement projects in their country. And they discuss the project. And they say, well, what could we give you as funding? And what do you expect more or less could be co-effects. So it's more rule of thumb. Right? Not anymore that you say, well, we assess this. And say, there are good reasons for this, not only the cost, there's also the reason that you cannot really evaluate the co-effects. Yeah, because they will arise in the future. Some co-effects are hard to monetize. Yeah? How do you assess gender justice, yeah? If there's such an effect? So the opinion was, well, better to be not so clear with the accounting of effects, but saving transaction costs. Yeah? And especially when you cannot really assess future co-effects, the question is, can we really generate more efficiencies through it? And indeed, this was then the policy. Jeff skipped this, this accounting. Yeah? And from a transaction cost point of view, this could be a good solution. Yeah? But then you do not have any more these polar cases of net or gross incremental cost. Yeah? Or you just say, well, we pay you the full cost. Then you don't have to assess the co-benefits. Could also be an option. Other problems which could arise with such transfer schemes is if you have to assess co-benefits in such schemes, you have also to take into account that there could be knock-on effects. This has been recently also addressed by Deneve and Jeffrey Sachs in a paper. So how can you assess that the reaching one sustainable development goal, like clean water supply, how can it then, as a secondary effect, influence other sustainable development goals, like poverty reduction? How can you assess this? This is quite challenging, and the question is, should this be done given high transaction cost? Yeah? And given the high uncertainty of the assessment? Yeah? So here again, the gross incremental cost method could be better because you don't have to net out anything. Yeah? Or you use incremental reasoning. Yeah? And of course, there are critics which say, well, if you have incremental reasoning and a rule of thumb, you have no clear criteria and you disperse a lot of money. Yeah? So it's not so undisputed. How do you assess international dynamics? Yeah? So you could have effects on other countries, for example, through your climate protection activity. Here again, same result. Yeah? The cost-effective net incremental cost method may not be so attractive. Yeah? So if you just take standard textbook economics, yeah, some of the outcomes are clear, but if you take into account transaction costs and other criteria, things become more complex. So, yeah, that's quite difficult. We did, I don't know whether Stefan yesterday, he talked, not here anymore, okay? Okay, sorry. I don't know whether you mentioned this paper. Okay. Here we looked at what effects could a coal phase out in Germany have on exporters of coal, exporters of solar technology. Yeah? Will that influence these exporting countries' attainment of their sustainable development goals? Yeah? And it's more tentatively, I mean, just to indicate there will be effects on other countries which do not accomplish this policy, this climate policy, but they are benefiting or suffering, yeah? And there's an indirect effect on their sustainable development goals. How can this be taken into account, yeah? Again, assessing ancillary benefits will be highly challenging, yeah? Okay, let me summarize. We have here two different concepts, which are polar cases, which make them, in a way, attractive for presentation reasons, yeah? Because, yeah, it's quite easy to distinguish them. And of course, cost effectiveness would be in favor of the NIC scheme, yeah? So that it would serve best the intentions or the rules of the JEF. But if you include other aspects like transaction cost, things may become less clear, and this led to this change in the policy of the Global Environment Facility. And this is something one should take into account also for future schemes. Yeah, the Green Climate Fund also uses such tools of incremental reasoning, for example. Yeah? And they should be discussed. I mean, is it good to save transaction costs? Yes, it is. But what would be the cost concern? I mean, it becomes quite blurred. How can you make sure that money is not misused? Yeah? How can you make sure that really the best options are chosen? So we have to weigh two different objectives here. Yeah, knock-on effects, how can they be evaluated? Yeah, lower transaction costs would advise us to take no scheme where you have to assess co-benefits. Incremental reasoning could be, as I said, some solution, but it's rather vague. Yeah? Surprisingly, there's little criticism of this concept yet in the literature. Yeah? I found an unpublished paper where there was a fierce anti-position. So there was somebody very harshly criticizing this concept. I think a lot has been to be done here, to be discussed. How can we structure better such concepts? Yeah, now let's finally turn to the CDM premium or SDM scheme, which could be a future scheme. Possibly we will see more, I think, in this winter when there are further climate negotiations. Yeah, this could be if you artificially introduce a requirement to have higher co-benefits. This could be, of course, at the expense of the climate objectives. Yeah. Again, you can say, well, goals are, we have 17 goals, we have 169 sub-goals. You can have the attitude that they are equally interesting, important, or you could say, well, we have some priorities. Yeah? Depending on this, you should take a look at different concepts of cost effectiveness. Yeah? Anyway, if we include such schemes, climate protection will become more expensive. There's a willingness to pay studies stating that there's a high willingness to pay for such premium schemes. The fact is, however, that in the past it has only become a niche market. Yeah? So I'm not so convinced that the willingness is really so high, because why was it then a niche market? Yeah? Okay. The scheme may be cost effective concerning co-benefits, but it could also not be the case. In any case, it will be attractive for the host country because it can sell higher hanging fruits, more expensive carbon projects to international investors. Yeah? Okay, but cost efficiency may nevertheless be pending then, yeah? Because of rising costs, which may not be justified by maybe lower increase in in benefits. So raising co-effects artificially may not be desirable throughout because finally, if we now turn to the demand side, there could be less demand for these projects, and with it, a lower amount of such projects accomplished, and with it, of course, less mitigation globally. And now, turning to Tinbergen, maybe we need more strength in other tools, yeah? Not using climate protection as a tool to solve all problems, but to have additional funding of like development aid. And if I look at Australia, which has been highly discussed, yeah, rebranding money, yeah, I think probably implicitly this happens also in other industrialized countries. Rebranding development aid as a climate protection aid, yeah, is something where one should take care of. Yeah? Possibly it's better to have different strands of policy, of course taking into account synergies, but I would be a bit skeptical to say that we can kill two or three birds with one stone. Quite complex. I cannot capture all with this simple modeling. I hope it gave you some thought, a lack of optimism also, because we will probably not find only policies that serve all goals simultaneously. Thank you very much.
Thank you very much, Professor Wilke. We've got time for one question, probably. Yes.
So as you were talking through this, if I understand properly, we really have sort of a calculation and information problem in the sense that I would like to invest some money, or someone like me would like to invest some money in this project in somewhere else, and it generally in your head is somewhere else, right? Like, and you would like, hopefully, this to have some benefits there and for it to cut carbon emissions. And I have to figure out if this project is, actually cutting carbon emissions, or if someone is being drastically hurt by this project and I just don't know about it. And the current sort of mechanisms you've talked about are sort of either I can sort of, make a couple calculations in my head and guess, or I can hire some consultancies and pay them more money than God and hope that they fix this, they tell me. And I was wondering if there might be sort of, we could draw from our toolbox of economists and think about maybe participatory ways in which we could negotiate these. So one could be that if, sort of you put if there is something that you are turning into an EU climate development certificate or something that happens in my state, say, and I am unhappy about it, I have some, sort of petition rights, and then maybe if this is, you could think about ways in which you could, I like solutions that involve randomly selecting people, but you can pick whichever sort of way in which you want to make sort of participatory groups of people whose job is to review these petitions and actually see if these things are working. And instead of trying to have someone who is far away and more expensive, try to figure out if this is working, if there are in fact decentralized solutions in which we can get feedback on whether these are working. And I just want to sort of leave that with you and see if there could actually be sort of bargained solutions, or sort of, we could create kind of local information feedbacks to actually figure out if our projects are working from the ground up versus trying to calculate it in places that often we know very little about, or we have really not a strong ability to get a good answer from.
I'm not fully sure whether I understood everything. I have hearing aid, and for me it was quite difficult. So your question is concerning whether there could be central solution or decentral. Yeah, maybe can.
Yeah, sorry, I do have a thick accent. So my question boils down to, currently it looks like these solutions are trying to think about ways in which someone can evaluate the relative costs and benefits of a project that is happening in a place that they likely know very little about. And what I'm wondering is if we can think about instead creating some sort of mechanisms or some sort of processes where whoever lives next to this project, whether it's me or someone I've never met, or can give meaningful feedback, and essentially we can sort of transfer some of the bargaining power to whoever is affected by this project, and then the people who are attempting to do this project can be forced to have some sort of negotiated solution with the stakeholders, and that might work better than us trying to calculate it. Yes, it is essentially we are trying to decentralize this decision-making process.
That's in fact the case. I mean, I'm not expert with such certificate systems, but the gold standard, for example, does so that they involve stakeholders. Yeah, and investors were sometimes happy about that because they said we want to invest. Yeah, and if the local community is against this investment, yeah, there will be some problems in the future. It's not sustainable for our investment, so we prefer to pay a higher price where they are involved, and we could solve this outcome. I'm very sympathetic with this decentralized proposal, yeah, because I do not think that the international contract can solve all this, could settle this, yeah, and I see the benefits because there's also bargaining power. Yeah, some developing countries are weaker, so they could be exploited. If you have a general rule, they're a bit prohibited. Yeah, but my impression is if you have a developing country and you would have well-established democratic institutions, they would know the best whether it's acceptable for them or not. So that's what I wanted to make also a point in the end. Helping or supporting development, maybe also in supporting democratic institutions, is also in a way could have a co-benefit in other fields, yeah, and could be desirable. But of course, there's this question of bargaining power, which would say, well, let's do it centrally, that there's a kind of force. But of course, economists are frequently that way, let people decide. Yeah? I think, of course, could be approached now to say, well, we use this gold standard where in advance stakeholders are asked. I have to admit, I learned a lot here in the school, and I'm still in the process of what can I learn from this? Yeah, what would be a solution? And I think nobody will tell you this is now the best or this is the best. Yeah, I see also advantages here which I've not talked about this the premium scheme. There are also advantages I see. Yeah, I'm not against it in general. Yeah, but I also see disadvantages. Yeah, and I think a good idea could be also to think really about local communities. How can they be involved? And let them decide more on decentralized level. And so I fully agree.
Thank you very much. I'm sorry we can't take any more questions right now, but I'm sure you will find Professor Wilke later and can maybe ask him more questions. I know there are more questions, but I'm very sorry we're running out of time. It's a lunch break now. We are meeting at Ratskeller, and the next talk will start at 1:45, so please make sure you're here on time. Thank you very much.
Okay, hello everyone, welcome back to our next session. The first person to present this afternoon will be Dr. Imke Roden. She agreed to jump in as a substitute for Dr. Lisa Schipper, who cannot come, unfortunately. And the talk you're now going to hear will be about the automotive industry and is called Nothing But Hot Air. So the stage is yours.
Yeah, thank you, Anja. Yes, I'm sure you probably expected someone else. As you noticed, we had already a switch of talks in the morning. And usually, normally, the talk that would have come now would is called Climate Compatible Development and the Gender Gap. And this is unfortunately not today the case. I'm not going to be talking about the gender gap. So yeah, sorry for all of you who wanted to hear something about that. But I hope you're now well fed after lunch and yeah, open-minded to hear something about the automotive industry. And it's not as much about the gender gap, but more about the automakers' communication gap, if you can say so. But still, it's about climate-compatible development, in a sense. So my name is Imke Roden, and I had this idea together with my dear colleague, Chris Ball. We thought about some automotive manufacturers, and of course we were working on papers about e-mobility. So then what came to mind is Tesla and its unusual story of conquering the market of electronic vehicles and being totally successful, at least in the media's view. And people seem to like it, and so we wanted to look a bit behind what automotive manufacturers are going to do. Generally, to start, I'm going to show you a few news flashes. The automotive industry seems to be leading not only the mobility movement, but also the clean mobility movement, and it is expected that there are going to be huge future developments. The car makers, of course, seem all to follow in some other direction, like going into EVs. Hydrogen-powered cars are not that much a big topic, but still, manufacturer after manufacturer is making commitments to dedicate resources into developing electronic vehicles further. Still, however, there are remnants of the diesel scandal, which I'm sure you all have heard about at some point in the last years, where the former VW CEO is charged with false testimony. And actually today, there is the official start of the trial, where charges are pressed not only against the VW CEO, but also against some executives, and they are not only charged with false testimony, but also severe fraud. But still, today, the Volkswagen CEO still has some air to breathe, because his trial is put a few days back and separated from the trial taking place today. So, yeah, we have to treat what automotive manufacturers are saying to some degree with caution. This is also what some other media is saying, because they suggest that it's maybe too easy for automotive manufacturers to say they are being green and are dedicating resources into new clean mobility techniques. And it also suggests as well that it is easier talking about doing good green stuff than actually doing it. I'm sure you all know why this is a serious topic, because we have something going on that's called climate change. So the goal is generally to minimize global warming. And as you can see on this slide, there are some current policies that will probably result in a target increase of degrees from 2.7 to 3.1 degrees Celsius, which is not enough. This is the upper blue field. And then there are pledges and targets, which are a bit lower, but still not able to reach the committed goals. Even the optimistic net zero targets don't seem to be able to reach the goals we have to set for ourselves. And the 2-degree consistent efforts probably are also not able to manage. We cannot say for sure now because there's still some uncertainty. And to be consistent with the 1.5 degree increase, we would have to increase our efforts by a huge amount. And you can see, of course, the huge gap between the different goals, the pledges, and the current policies. And this is, of course, where the sustainability movements all around the globe have their roots. And there is the Global Paris Agreement, which also says that it's not on single sectors, but all sectors have to contribute to reduce so that we can reach at least the most of the goals in reducing that we are able to. And the transport sector, which is here marked, has also a quite large share to do in reducing. Otherwise, we won't be able to reach any goal at all, if I can say so. So this directly and this huge challenge that the transport sector and, of course, the industry as well have to face among the other sectors leads us again to the role of the car manufacturers. And of course, the importance of the car manufacturers for the industry and of course as well for the economy. Not only in Germany, the automotive sector is economically important, but also in the EU, where the transport is making up 21% of all European EU CO2 emissions. And when you only look at the production processes of automotives, then the production of one vehicle amounts to 0.6 tons of CO2 emissions alone. When you look then not at the ordinary cars with internal combustion engines, but at battery electric vehicles, and they seem to have a higher manufacturing footprint, which is due to the batteries that occupy a large share of the emissions during productions, because the technologies and the materials that are needed to produce this battery also add to the normal production emission value of a single vehicle. Sometimes it's said that the battery alone adds up to 60% of the emission per vehicle. But not only the specific production values are important, but as well the socio-economic relevance is critical, because the automotive sector in the EU, for example, has a share of 6.1% of the total EU employment, and it contributes to 7% of GDP. And this is only the automotive sector, as the sector, as you all probably know, also affects other industries that deliver to automotive industry and manufacturers, for example, steel industry, chemical industry, and the information and communication technologies. And when we look at this and the ideas to try to combat climate change and to reduce emissions, then we have to think about the change change in technologies. What change in technologies is possible, and will this affect the economy? Will this change employment, not only in the European Union, but also globally, of course, and on a national level as well, depending on the shares of industries that contribute to the national GDPs. Mostly, the focus has been on a system-level change. When you look at the different industries and their climate contributing potential, and you have to think about how to make this change. And you can, on the one hand, think about, for example, Tesla as an emerging David that is competing against the so-called greening Goliath of the old manufacturers. And this is somehow speaking for a view where Tesla is able to disrupt by innovating in a sense and disturbing the whole manufacturers industry and somehow being successful, albeit not that economically, at least at the start. So innovation, which is coming to a part from Tesla and as well from the other older manufacturers that have been longer on the market, is most important driver of change. And this is very important that you try to achieve increases in innovation to be able to combat the climate harming emissions. And Tesla, you have to say, is one example which mostly disturbs all analysis that you make about the automotive sector. Of course, they only produce electric vehicles and no other conventional cars, but they are so exceptional because of their high value products and because of the factor that is called Elon Musk, because his personality also contributes to a part of the image that we get by Tesla. And when we think about what we want to convey when buying and driving a Tesla, this is something else than when you decide to buy a small Nissan Leaf because you're really trying to be economically conscious. Still, the contrast between Tesla and other manufacturers that are still relying heavily onto internal combustion engines is that you have to think about the path dependency. The old incumbents have to adapt somehow into the new world with the new technologies and other possibilities to propulse cars. And just because Tesla says, hey, I'm Elon Musk, I can do this, this doesn't mean that a manufacturer like Volkswagen is able to the same degree to be so disruptive. So, whereas the body of research has this more system-level focus and change, and treats the manufacturers more like the new disruptors and the old incumbents, this says little about the actual position or performance of the manufacturers, and we propose to consider the manufacturers more differentiated and not just like this is Tesla, this is Elon Musk, and these are the older manufacturers with the longer history that are just trying to get by and rely too much on the internal combustion engines. So policy can of course help there. But there are limited to exogenous factors, and the process itself is difficult to set as there are no real insights into what the manufacturers are actually planning to do. They are saying some things, but they might do other things. And we wanted to investigate if we can tackle this possible discrepancy. And so we looked at 22 automotive manufacturers all over the globe. We selected these because they make up about 90% of the total automotive market when you look at production. And you see here the size of the bubbles in blue and pink. This contributes to the market share. So the larger the bubbles, the larger the actual production and market share of these manufacturers is. And we selected a variety of German manufacturers, American, Chinese, Korean, as well as other European manufacturers and consortiums. So we just wanted to know what they are doing based on what they are telling us. And for that, we looked at what the manufacturers publish as so-called sustainability reports or environmental report, or however they might call it. You can see here they are talking about changing lanes. They have a road to sustainability, and this are large reports for some manufacturers where they state what their plans for the future are. They state how they're going to tackle the climate change problematic and what their key indicators are that show how they are doing. Some of the manufacturers don't have huge reports, but only smaller ones. So it's very different, but we selected at least of each of the manufacturers 3 reports. So we wanted to look at how they are presenting themselves. And this leads then to the research question, which is how sustainable do car manufacturers claim to be? Where is their focus in sustainability? And how does the reality actually look as far as we can investigate it? So we took the sustainability reports, we put them into a so-called topic model, and then we checked the topic model results with a seemingly unrelated regression model, which I'm going to present you now. Topic modeling in general is a form of text analysis, not necessarily text mining, but text analysis in general. And you can investigate not only documents, books, articles via text analysis, but you can apply the topic modeling approach also to videos or images or all other different forms of media, because it's based on the latent Dirichlet allocation algorithm, which is a generative probabilistic model of a corpus, and a corpus is a set of different documents. And in our case, a document is a sustainability report. So we just collected all of our reports and built a corpus to apply the topic model. And for the topic model, it's that the documents we have, the reports, are represented as a random mixture over the latent topics, where a topic is characterized by a distribution over words. So we have different words, which are marked here with the W, and different topics, which are here marked with a Z. And those are in one document, and then there's a replicating repetitive process to investigate what words are frequent in those documents and to what topics could they possibly belong. And this algorithm does it automatically and unsupervised, so I don't have to tell the algorithm what I'm looking for. It is able to convey the topics by itself, and then I have to look at what the results are. So this is what our topic model was exhibiting. So we were able to set the number of topics we wanted to achieve. So we had to, of course, do different tests with a number of 4 topics, of 3 topics. We also did 5, 6, 7, and more topics to just see what number of topics is able to give us the best and the most clear view about a possibly sustainability focus of the different reports. Because we wanted to identify different themes in the whole set of the reports, so that we can say in all of the sustainability reports there is a focus on the words and topics of the first topic, and there is another focus which consists of words and terms of the second topic, and so on. And it's also allowed that the words and terms can overlap. So this is also necessary, of course, because we are just looking at sustainability reports. It's clear that it's about sustainability, what they are writing, and so we try to identify the different parts of sustainability a manufacturer can focus on. We then decided to aggregate the different terms of the topics. What you see for each of the topics is in the first row the most frequently named term or word, which is, for example, for topic 1, environment, and for topic 2, it's product. And it is possible that topic 3 and 4, like you see here, have the same most mentioned term, which is vehicle, which is probably obvious because, you know, it's about automotive manufacturers. And we also removed all other words that had nothing to do with the reports themselves. For example, the names of the manufacturers, the brands. We excluded them so that we get the best view of the different topics for the reports. And then when we decided on these six topics, we looked into the reports again to see if we can reasonably say that we want to name the first topic, environment, that we want to name the second topic, production, and the third, emissions, fourth, globalization, fifth, company development, and sixth, management, which then should be the emphasis of each topic. So it's obvious that we had to aggregate somehow, and it's a bit difficult because the word emission actually appears in 4 different topics at different positions of frequency. But when you then combine this with a literature analysis on the different reports, then you can say the actual focus of the manufacturers goes into this direction. And this is only, of course, sustainability focus. It's not generally environment, but it's environment within sustainability. And it's not production as a more general thing, but it's sustainable production. And it's, of course, as well sustainable globalization and sustainable company development, all with a focus within the different reports. And how were we able to make this literature review? Of course, because the algorithm also tells us what manufacturer belongs to which topic. So after we got the 6 topics, we looked into each of the manufacturers' reports to scan them and see if they fit into this topic or if the algorithm wasn't reliable in its outcome. So for the first topic, you could probably say under all assumptions that we had to make, that Suzuki, Mitsubishi, Dongfeng Motor, Toyota, and Chongqing Chang'an are focusing within their sustainability on environment as a whole, whereas BMW, Volkswagen, and Daimler are focusing on sustainable production, depending on what they are writing in their reports, of course. But we now got the 6 topics. We know which manufacturer is following along to which topic. So we want to now check if they possibly are actually sustainable. And for that, we took the indicators the manufacturers provided in their reports and in other documents such as financial reportings and other data we could obtain to see if there is something behind the talking which they do in the reports, and if there are some of the indicators related to some of the topics. So we also collected data on the CO2 emissions per vehicle produced, which looks at the CO2 emissions of one vehicle of the production of a manufacturer. And we also looked at the share of electrified vehicles. We looked into R&D expenditure, and to cover a bit the economic importance, we also looked at the revenues of the manufacturers, and we included a societal factor, which includes the origin of the manufacturer, because we saw when we developed the topics and we did the estimations of the topics that you can see that the manufacturers seem to that manufacturers of the same or similar origin are in the same topic, which is when you look here, you could possibly say that there's a topic, the first topic, which includes more Asian-based manufacturers, and the BMW, Volkswagen, Daimler topic is obviously more European influenced, possibly. So this is why we also included a societal factor in the model. So we have the 22 car manufacturers. We covered roughly 8 years, depending on data availability of the manufacturers. And as I said before, we can try this with this reduced set of 22 manufacturers, because what they are making out is the share of the market that is 90%. So we say we have almost all manufactured vehicles included and all relevant automotive action. And this leads us to the regression model we applied, which is a seemingly unrelated regression, which should probably be better called a seemingly related regression model, because it's a model where you have multiple regressions. Like here, we have for each topic one regression with different dependent variables, which are here the topic names. And we applied the same exogenous variables, which I just showed you the slide before. So this only is different depending the dependent variables and the error terms, because the normal OLS model is not efficient, because the different topics, which are represented as the dependent variables, are correlated, not only because they are overlapping in terms, but also because they are all different sides of sustainability. So we do, in this seemingly unrelated regression model, a simultaneous estimation of the parameters of an equation and take all other equations into account at the same time, which results in the correlated error terms, so that we then have a result for like a normal regression, but we take into account that the topics may overlap. Yeah, the results are, I will say, mixed. We have some positive effects of the regression model, which are for R&D expenditure, for the share of electrified vehicles, and for CO2 per vehicle produced, but only for certain topics. And these are only the significant effects, which you also see in the little table. And we have ambiguous significant effects for the societal factor. So although we expected that it would be a clear influence in one direction, it seems to only matter for some topics in a certain direction. For example, for the third topic, which is called emissions, the effect is significant and negative. But for the sixth topic, which is management, in the last row, the factor is significant and positive. So this seems a bit ambiguous, but we have to say in general that all effects vary over the topics. We have no estimated effect that is the same for all of the topics. And we have only very few significances, so these are the ones in the table. And generally, we have to say that the effects vary, and we cannot make out a clear-cut picture. So the conclusion is probably that for different topics, different indicators are relevant. So we have to look at sustainability in a more differentiated way than just saying, yeah, it's sustainability and they are all doing like the same. Okay, they may have a focus on different technologies concerning their products, but still it's really better to not separate them just in the new disruptors and the old incumbents, but try to view them more differentiated based on what their actual strategy seems to be. And this leads then to this conclusion that what they are saying might not be the complete truth, and that the problem with the car and automotive industry doesn't result only from the emissions the vehicles produce, but as well from the things the executives may say. Because a main issue is, and I'm going to be clear, that we have to rely on what the automotive manufacturers are saying. And we have to rely on what they are telling us. Because the reports are going to the PR departments of the manufacturers, of course, as everything else. And we do not know for sure if it's the actual truth. Even with the indicators about how much CO2 a produced vehicle emits. This is also not clear if they are really telling us the truth, because when you try to investigate how large the numbers are, you find so many different possibilities to state and to give an information about the CO2 emissions of the production, that you have sometimes trouble to combine them into a data set which consists only of one indicator. But you have to make them comparable somehow, and this is a huge thing. So at this point, I would ask you to take a deep breath and think about what you could probably imagine that allows in some kind of way to assess the trustworthiness of the manufacturer's statements, because this analysis is showing that it is possible to investigate an interesting and relevant matter, to uncover how this very important industry works, but still, how can we know that what they are telling us and what the numbers are saying is really true? Because we cannot just go into the production and say, yeah, please let us see your numbers, your Excel sheets on how much emission the production emits. It's not possible. We could probably send an undercover Greenpeace agent to one of the manufacturers, and then in one moment when they are unsupervised, they can hack the computer and look. But this is of course not possible, although I would of course take funding for a project like this. But I really want to ask you, do you have any ideas on this matter? I would be happy to hear your suggestions how to assess this problem. Do you know of other indicators or organizations, or probably have other ideas on how to tackle this? Because they can say so much about how they are perfectly being sustainable and their production is so much improving, and they have such great plans for 2030 and 2040, and they want to raise the share of their electrified vehicles to the moon. I don't know. So please, I would ask you to raise your hand, and Anja will take your suggestions, which I will be very happy about to hear.
Thank you. I'm just one question first, like the TÜV, like TÜV, Technische Überwachung, something like this, Verein, who issues the driving license, also something like this. This organization is not looking at the, especially in Germany, I'm talking about Germany, this organization is not looking at the emission of vehicle? Yeah?
Sorry, which organization do you mean? I didn't...
TÜV.
Ah, okay.
Yeah.
Yes, but they are testing the actual emissions of the vehicles on the test stand, and this doesn't cover the emissions that the production...
The production process.
Yeah. And we want to know about the production process.
Mm-hmm. One of the ways is like looking at the life cycle analysis, you know. So looking at the materials has been used. Like what are the materials has been used in the car, and looking at the carbon, looking at the carbon intensity of the power system, definitely. Like what is, for example, if Germany is producing 50% from renewable, and looking at the how much energy, how much energy it could consume to process this kind of material. If you know the material composition of the car and the processing, definitely they will not disclose this information. The company do not, but the scientist can do a back calculation looking at the material processing.
Yes, that sounds interesting. Yeah, we will, of course, write this down. Thank you.
Yeah.
Yes?
Thank you. So it's following a little bit up what was said. You can try life cycle assessments. And of course, you have these general numbers for several industries, which are usually averages, but you can try to make specific data sets and looking at them. I just have to say it's extremely data intensive and would take a long time. And above all, there will be times where you would be forced or might encounter some difficulties in obtaining information from the specific car manufacturers. But you have also ways to go around it by making it obligatory, like in other products. So it can be, at least to a certain extent, a possibility to have some ideas and make comparisons, if not at an absolute level, but at least comparisons between car manufacturers.
Yeah, thank you.
Yeah, as an economist, I would say, take a look to the balance sheets. In the balance sheet, you have information about expenditure for products, for materials used. Of course, you have the problems with prices and so on, and correction of prices, but you have these expenditures for materials. You have also expenditure for employees. You have expenditure, maybe investment in R&D. So maybe looking on the balance sheets would be.
Yeah, thank you. That's a good idea. Yeah.
Thank you. One thing about trustworthiness could also be checking if they have an energy management system or EMAS certification. So just as a checkbox, because if they have something like that, then they already have internal and external audits that will have to be kind of certified that the numbers they are providing are actually true and should also be linked then to the energy management or environmental management system.
Yeah. This sounds great as well. Yeah, thank you. Yeah, we haven't looked at the certifications or audits yet, so this could be promising.
Any other comments here?
I think now many industry companies, they have to release their environmental impact assessment and also life cycle assessment. And for some environmental authority, and require such industry companies also to show and what is the result for the whole production. And now there are a lot of studies do life cycle assessment, especially in car industry, and now of course also for mobility.
Yes, thank you. Yeah, life cycle assessment is also some strength of one research group at our institute, so I will definitely make an appointment with the colleagues. Yeah, I think, was there any other idea somewhere? Or you? Yeah.
Thanks much. Just short a comment. What comes to my mind is about the location of the production. Actually, to my understanding, some parts of this car is produced somewhere else, and then maybe, let's say, the company itself is based in European Union. Maybe there is no much emission, but most likely emission is occurring somewhere else. So it means kind of if you chase to this value chain, perhaps you can find out how large is the entire emission from the production process.
Yeah, this is also interesting because I think the manufacturers have spread their production all over different countries, so this could be interesting to look at the different standards. Yeah.
Anyone else? Okay, I don't think any comments.
Is there?
Oh, sorry.
I think my suggestion kind of refers to the one suggestions I already heard, because as we have in Germany, we have the system of scope 1, scope 2, and scope 3 emissions. So one could look at each of them. Like the third one would be the one that we already just heard, one suggestion before, that we look at the outsourced parts. But that one is, I think it's not implemented yet, but the first and second ones are implemented, and I think one should be able to access those informations.
Yes, exactly. We also had some data about the different scope emissions. Sometimes we got scope 1, 2, and 3 separately. Sometimes 1 and 2 are merged somehow. So it's some of the manufacturers are definitely stating information about this. So we could actually look into the protocol standards again and then try to see if the manufacturers are somewhere publishing separate or more information about this. So this is also a good idea to maybe just collect that over the scope indicators. Yeah, thank you. No, I'm not ready yet. This is thank you. Then I would thank you again for your ideas and switch back to the other microphone. Because I now have to finish the talk in general. So yes, this was the starting statement of my talk. This was what we started with. We wanted to find out if it's nothing but hot air, what these automotive manufacturers are spitting out in a sense. And our conclusion is that it's probably mostly hot air, which is said nicely, I think, but there is potential in the approach and in the implications that we can reason in our work. So we have to think about the different consequences, of course, and some of the consequences are also mirror what you thought about a bit, because the consequences should be to address this discrepancy within sustainability somehow and look for differentiation in the automotive sector. And together with emissions and reporting standards, we have to think about if we want to develop some set of framework where we can assess the sustainability properly and make it not just following the will of the manufacturers if they are disclosing information or not, and what information they disclose and in what form, because actually at the moment I didn't want to say terrible, but it is actually, for some manufacturers, the information you can get are just blurry bar charts, and then you have to measure yourself what the actual emissions of the productions may be, and they don't supply any other informations. So this could be a good step into the right direction. But it would, of course, also require that when we set up standards, we have to have some organization that does it, and that there is a monitoring process or an evaluation, and there have to be, of course, some kind of consequences probably, so that we can guarantee some type of credibility. And we need clear standards, of course, and maybe possibly support into research and development to facilitate more advanced mobility concepts that are clean concepts. And it's also important to pay attention to the general electricity mix, because if we are fueling a battery electric vehicle with 100% coal electricity, like you can see on the far right, then its emissions, at least from the use phase, are much higher total than when you just drive a normal internal combustion engine car. You can see in the blue parts, this is the vehicle production and disposal. The yellow parts, orange, is the fuel production. And even when the energy mix is wrong and not climate friendly, it doesn't matter if you drive a dirty diesel car. So this is also something which has to be taken into account, at least if you look at the complete phase of manufacturing and using a car. Because zero emissions vehicles are really difficult and into different concepts. So these would probably not suffice if we don't have clean electricity mix that powers those cars. And of course, at this point, I also have to say that we have to think not only about cars, but also about other forms of mobility concepts. Because just with cars, the targets can probably not be reached. So, coming to the end now, this is the final slide. We have some important leverages which are the result of the analysis we did, at least depending on our assumptions. And those are that the share of electrified vehicles is important, and research and development expenditure is again an important leverage for increasing innovative activity and thus contributing to clean industry. So there are, of course, targets that should be set up, and those should impact on sustainability. But still, there is some work to do on the data restrictions. We talked about it shortly, because we can only trust what we get from the data. So we just have to find ways to assess if the data that we can obtain is the truth, or if it's just lies or hot air. So this is an important point, and of course we can think about the identification of the topics themselves, because sustainability is still a broad field, and without a concrete framework, it's hard to make out distinctive directions, and of course it's hard to monitor and assess the truth behind it all. And with this, I thank you for listening, and I thank you again for hearing this talk today instead of the other talk, and I'm happy now to hear further questions and comments. Thank you.
Thank you for this very interesting presentation. And now, as you already mentioned, it's time for questions from the audience. Who would like to start?
Thank you very much for your presentation. I just have one quick question regarding the number of observations that you had. So in your regression table, you listed 22 observations. So I was just wondering, is it 22 observations in total, or is it 22 car manufacturers that you are taking into account?
It's 22 car manufacturers, and I think it's about 50 or 70 different reports in total, because this was the maximum amount that we could get, because not everyone is publishing a report yet. There are some reports are small and short and more like a PowerPoint presentation without much text. Some reports are really long. Some reports are not in English. We had one manufacturer where we had to translate a Chinese report, which worked because they had English headings, and then we could check what the translator told us. And we also had not for each and every year and each and every manufacturer a report. Because some of the manufacturers some of them started like 2010, some of them started 2017.
Yes, and this is actually my second question. So what you are running and estimating is unbalanced panel data, right? Or am I wrong?
We have to do some, we had to take averages. So because we have too many missings to do a panel data set. If we wanted to do a panel data set where we could impute the missings, then we would have probably 3 years data or 2. I'm not
So
sure.
how many observations are actually taking part in the regression? So this is the important part, right? Because all your tests and all your interpretations are actually dependent on this.
Yes, then when you talk about the regression, it's 22.
Mm-hmm.
Because we don't have don't have more manufacturers that are relevant to the market. This is, I have to admit, a bit specific about the industry, because when you look at the different manufacturers, you could look at the different brands, but they don't have a report for each brand. They have sometimes multiple brands under one roof. So this is a small set of observations. Yeah.
So what you did now, and now I understand. You took the averages and ran cross-sectional regression, adjusting for the correlation of their.
Exactly.
Thank you.
Anybody else? Here.
Thank you very much for a very interesting presentation with a lot of food for thought. I was wondering, on the average, have you seen some kind of trends in terms of depth in each manufacturer throughout time? For example, have you seen differences that would stand out by car manufacturer, for example, throughout the years that you analyzed?
Thank you. We didn't look into the time series development yet, because it's usually not nice to always say, we didn't have any data, so we couldn't do it. But partly it's the truth, because we could probably observe some changes. We could observe changes in the indicators. Yes, that is what we can do, but not in the topics or the directions or the focus of the manufacturers, because then we would have too few documents for the topic model. It could probably work, but they are often even changing the concept of the report in some year. They have some report for 3 years, and then they totally change the concept, and not the design, but the concept, the extent of the report, and this is why there's then a break, and because we only have so few years, because then the break may be 2015, and we have 3 years before and all of the years after, but it's short. So this is quite an analysis that is very new. So it would of course benefit from more data as time goes on. Yeah.
One more question, maybe. We still have a few minutes, so a short question would still be possible. Okay, I think we don't have demand for this. So thank you again.
Thank you.
And we will proceed to the next presentation, which is given by Professor Frank Wetzold from Brandenburg University of Technology. and he's going to talk about tropical forest conservation.
Yeah, hi everybody. First, thanks for the invitation. And yeah, my name is Frank Wetzold. My main field is actually economics of biodiversity conservation. And so when Dirk Rübbelke asked me whether I want to present here, I said, energy, climate, well, it's not really my main field. And then he said, yeah, but we're also talking about co-benefits. And then we moved to the area of co-benefits between climate change mitigation and biodiversity conservation. And then, okay, I must admit I'm a bit out of my comfort zone here, but I remembered that, well, we had a nice project in Madagascar, of which I will say a bit. And usually I'm much more working in Europe, and working more on agri-environmental schemes and applying ecological economic modeling. But I still hope that what I'm telling you here is interesting and yeah, it gives you some inspiration and insights. Okay, that's the kind of, if we do a presentation, somebody from the chair, this is like our, yeah, how to say, a sign. It shows a bit what we are doing. On the left, you can see an interview a former PhD student did in Madagascar. And we also do choice experiments. So that's a choice card. Then we do a conceptual ecological economic model landscape. Very often we have like these artificial landscapes, which you see in the middle. And we do, as I said, agri-environment schemes. We do software development. DSS EcoPay is one of them. That is what you see on the right. Okay, so now let's move to the topic, the presentation. What am I going to tell you? First, I will briefly address the question. I guessed that from your background, or from the background of the presentations I saw, that you're not too familiar with biodiversity conservation and with this topic. So I will first talk about why could there be co-benefits between climate change mitigation and biodiversity conservation. Then I will, after I develop the idea why there could be some, I will look at whether there are some. And then if we want to kind of harvest them, what could be a potential policy background? And there I will say a few things about so-called REDD+. And then, and this brings me to Madagascar, I will present to you a case study, and that is about opportunity costs of conserving a dry tropical forest under REDD+, the case of the spiny dry forest in southwestern Madagascar. Okay, that's the plan of my presentation. And we start with the first question, why could there be co-benefits? And if we look at estimates about the contribution of tropical deforestation, but it's mostly tropical deforestation, to global warming, then these estimates range between 10 to 17%, but it's very difficult to quantify, so the changes, so the estimates change, and it also changes over time. For example, in Brazil, for quite a number of years, you had severe deforestation. Then the political situation changed. You had less deforestation. Unfortunately, now deforestation has increased again. So it's a bit difficult to pinpoint an exact number. But it's quite substantial. And if we talk about biodiversity side, also we don't have precise estimates, but again, a good number might be that 2/3 of a species living on Earth might exist in tropical rainforests. So the idea is that if we halt CO2 emissions from deforestation, we also automatically, but there's a question mark, to which I will come back later, conserve a large part of Earth's biodiversity. So there would be really, if we really manage to stop deforestation, there would be huge co-benefits in terms of biodiversity conservation. Let's look a bit more at the evidence, and for this I have taken a couple of maps from several articles, and here you have two maps, one on the, sorry, I see here black and white, and there's colorful, and I remembered colorful, I'm a bit confused. You have two maps, and one, the map on the top, is a map of above ground and below ground biomass into carbon, and the map at the bottom includes soil organic carbon. So then we can identify the total carbon density map. And we are interested in the tropical forests, and you can see, especially if we talk about above ground biomass, so we look at the top map, that around, if you go along the equator, roughly from South America to Africa and then to Southeast Asia, the CO2 content is very high. The more brownish it gets, here the more blackish, the higher the CO2 content. So there's a lot in the tropical forests. And here we look at biodiversity, and that is a study based on the data from IUCN, and it shows priority areas for either proactive biodiversity conservation, meaning the areas that where biodiversity is still there and can be conserved. That's here, and on the other, I will just go to the next slide. And so we look at here the colors. We look at green, and green areas are areas where we have high local biodiversity, here understood as high richness and range size rarity of the species remaining in an area, high local intactness, high average habitat condition across the broader area supporting or previously supporting species of the location of interest. And again, you see that in the tropical forests, that is like the map below, there is a lot of biodiversity of these areas. They are still intact and can be preserved. This map, the one at the top, shows the areas that are already, there has already been some degradation going on. And here, so it's priority areas for reactive conservation actions. And here again, we see the tropical rainforest, if you go along the equator, having quite high areas or areas of high biodiversity conservation. And the bottom map shows the top 20% top quantiles for both biodiversity indicators, and again you see that's here around the equator. There's quite a lot. So we have looked at a map of carbon storage, and we have looked at maps of biodiversity conservation. So now we look at a map that covers both. And if you see at the explanations, you see that the more brownish everything is, the higher you have like 100% priority area. But that's here for the this is for the areas where biodiversity is still intact. And again, you see the brownish areas along the equator where you have the tropical forest. So we can already answer the question, there would be lots of biodiversity, there would be lots of co-benefits. And here we see on top we see the reactive part, the reactive measure, and again there we also see that it's along the equator. Okay, so basically we can answer this question with yes, we have huge co-benefits between biodiversity conservation and carbon sequestration if we focus on tropical forests by and large. So how could we then turn this into practice, or what options are there? And this brings us to the mechanism or the idea of REDD+. And REDD+ started, or the idea of REDD+ started to come into the policy process in 2005 at the Conference of the Parties in the 11th session in Montreal. And there the idea of reducing emissions from deforestation in developing countries became like an official policy goal, so to say. And you probably know that COP is an annual meeting within the United Nations Framework Convention on Climate Change. It takes place basically every year. And there it was politically recognized. I mean, of course it was obvious, but political recognition is always something else, that the contribution of greenhouse gas emissions from deforestation and land use change in developing countries to climate change was substantial. Okay, and REDD then officially, also as a term, was launched 2 years later, in 2007, at the 13th COP meeting, and it became from REDD to REDD+, and so this REDD stands for Reducing Emissions from Deforestation and Forest Degradation. And the plus means that it's also the conservation of existing foreign carbon stock, also the sustainable management of forests, so management is allowed, it's not only conservation, and the enhancement of carbon stocks. So what is actually REDD+, or what is the idea behind it? The idea behind it is that actually huge amounts of money would go from the developed countries, which kind of already have destroyed their forest, to the developing countries to compensate them for not developing by cutting down their forests. So, I don't know whether you are familiar with PES, Payments for Ecosystem Services. So you can think of REDD+ as a huge payment for ecosystem services, namely from developed countries to developing countries for not cutting down their forests. That's the idea behind it. It is also supposed to be a cost-effective mechanism. Cost-effectiveness here meaning that those where you can conserve at low costs, that is what you can do, or there you actually conserve, and as economists, that should be, the idea is straightforward. If you have, say, a payment of, I make up a number, 50 euros per hectare for conserving the area, and assuming the CO2, the carbon content is the same in all these hectares, then those with low costs, with costs of below these 50 euro will conserve, and those for those conservation is very costly, then they don't conserve. So that is like the economic idea why it should be a cost-effective conservation mechanism. Okay, so if you have these payments from the developed country to the developing countries, then you may have co-benefits. There may be a variety of co-benefits. I already mentioned biodiversity conservation, but there are others. There could be poverty alleviation, especially if the money goes to the poorer countries. But there could also be an improved forest governance, as if the sustainable forest management goes into the REDD+ mechanism. And it is also said that it may help the indigenous communities, those who live in the forest. So in principle, REDD+ has the potential to deliver enormous benefits for biodiversity conservation, because what we have just seen, these tropical forests harbor a lot of biodiversity. Sorry, there's now one slide. Okay, yeah. So there has, of course, been scientific work on that. And so this is here the example based on an article by Oscar Venter and colleagues. And they looked at oil palm expansion in Indonesia. And this oil palm extension threatens, well, many species, but two charismatic species are mentioned here. It's the Bornean orangutan and the Borneo pygmy elephant. And these are just two among 40 globally threatened mammals. And they found in their study that if there are REDD+ payments, they could actually compensate for this revenue from oil plants and stop deforestation. If we assume a carbon price of, at this time, US dollars between 10 and 33. And, well, if you don't cover all, but just target some areas and cost-effective areas, then a price of between $2 and $16 is sufficient. And they found in their study that these cost-effective, low-cost areas also contain a high number of threatened mammals, indicating that in their case, there are synergies between mitigating climate change and conserving biodiversity. However, very often humans, we scientists, like these ideas of win-win situations. But economists are also there to tell the people that there are trade-offs. So let's look let's turn to another article from PNAS, a very recent one. And there they simulated the distribution of RED Plus funds, so hypothetical distributions, under different budget optimization scenarios. And wait, let me just briefly recall. On the left, and let's only focus on the top two pictures. And the more bluish it gets, the more you spend, and the more whitish there's nothing. And on the left, so top A, there's the focus on carbon emission reduction. And B would be a scenario where the focus is not on carbon emission reduction, but the focus is on biodiversity conservation. And if you compare the two maps, you see that there are synergies, for example, in South America, Chile and Argentina, but there are also obviously not synergies. So if you look at figure B, you see that in sub-Saharan Africa, some countries are targeted under the CO2 focus, and other countries, for example, like the island of Madagascar, they are targeted under the biodiversity conservation focus. So the study by Venter et al. That identified these win-win situations and co-benefits is a case study that is case-specific and may apply to some areas, but it does not apply always. And even if you ignore this targeting, RED Plus has a number of other problems. I don't want to go into details. I'm not an expert on RED Plus, but I would like to mention a few so that you are aware that this is not like something easy. And I personally must admit, the more I learn about it, the more skeptical I become about whether this is a really good, or not a good thing, but an easy thing to implement. The first concern is leakage. Leakage refers to a situation where you target a payment on a specific area, and then you may have two types of leakage. One is a direct displacement of deforestation to the neighboring area. So you, just to make the idea, to repeat the idea, you have a payment, you target one specific area, and then people just go to the neighboring area and cut down the forest there. So overall, nothing is won, it's just a displacement of activities. But you may also have indirect leakage. This is usually through the price mechanism. So you conserve the forest in one area, and then there is a decrease in supply of forest, and in the market equilibrium, you have a higher price, and through this higher price, there is a higher incentive for deforestation in other areas. So there may be direct and indirect leakage, and this questions to some extent the success of RED Plus. And it may be particularly troublesome if you focus the payment on a carbon-rich area and then leakage occurs in areas where you have a high level of biodiversity. But it should be also said that the problem of leakage occurs because currently there is no idea or no political will, of course there are ideas, but no political will to include biodiversity concerns into RED Plus. Of course it exists in principle, but this moving to biodiversity-rich areas is there because biodiversity is not a target. But there are other problems of leakage, and that's why a word of caution. First of all, you have to monitor success. And nowadays we have satellite data, and this is actually available on small scale. So it's pretty easy to, say, identify forest fires. You can see there's deforestation. But what about forest degradation? This becomes much more difficult to assess, even through satellite data, because you need to assess how much is it degraded, how does it calculate into CO2 reductions. That's pretty difficult and costly. The more detailed you become, the more costly it becomes. But with the ongoing development of satellite, remote sensing techniques, that problem may be solved at some point. But then you have the baseline issue. So when do you pay if something is when do you pay a country, say a country, for conserving the forest? Do you pay the country if it has no incentive to cut down the forest anyway? Do you still pay it? Do you pay a country, or actually, then do you pay a country only if it improves the performance? So a country that, only country where you had deforestation and now it stops. If you do it like that, you kind of punish those who have been, out of conservation interest, very much concerned about their forests. Countries like Costa Rica. Do you pay countries where you observe a decline, and then the decline somehow is a bit less? Do they still get money? So there are a lot of questions involved with these baseline issues which are not easy to solve. The next point is the question of scope. Do you pay a whole country or do you pay a project? If you pay a project, then of course you have, let's say that there's a national park and then you pay money for that national park, but that the forest is conserved there. If you do that, then of course you have the issue of leakage. They might just cut down the forest next door, next by. If you, in contrast, if you have the whole country baseline, then you might forego the opportunities to conserve some areas inside a country when others are kind of being destroyed. And we should remember that in many countries in the tropics, the governments are not very strong. They cannot enforce things. So also considering a whole country might just, might lead to money going somewhere, but without clear mechanisms. And those who are really interested in conserving areas might not even get the money because others just destroy the land in other areas of the country. You have governance issues. How do you control everything? How do you make sure, given that governance is usually weak in such countries, how do you control things? How do you ensure, for example, there might be fire outbreaks? How do you deal with that? Do you accept that there might be natural fire outbreaks? Or is it that some people might just pretend that there are natural fire outbreaks? It could be like logging companies or some those who want to do plantations. There are lots of unclear issues related to that. And then you have the issue of permanence. So you pay a country or a project for some years the money that they conserve their forests, and then after 20 years they still destroy it. Nothing is won for the climate. And you have the issue of liability. If there is a breach of contract, who is responsible? What are the but enforcement mechanisms? These are all tremendous problems. And of course, perhaps the most problem is that we need a huge amounts of money for that. Because if we focus on particular areas, the problem of leakage is there. And this money then should come from developed countries. That's at least the idea. And, well, the taxpayers have to accept that, and the taxpayers are voters. They have to accept it. And they may even accept the idea, but then if they see that some money goes into corruption, the mechanism will just kind of dissolve. I'm not saying that this is not working at all. As I said, I'm not an expert. But to me, it seems that the problems at the moment are tremendous. That was just my word of caution. Okay. Now I come to the case study. And this is about, yeah, I said it, opportunity costs of conserving a dry tropical forest under REDD+ in southwestern Madagascar. And what is the background here? Between 2010 and 2016, my group was part of a BMBF project. It was a huge BMBF project. It's called Zulama, Sustainable Land Management in Madagascar. And we, the whole group, looked at options to conserve Madagascar's unique biodiversity, but also at the same time to provide opportunity to achieve some incomes. And I don't know whether you are aware of Madagascar's unique biodiversity. To be honest, I was not before I became part of that project. Madagascar is an island and moved away from Africa at some, I don't know how many 100 million years back. And then they developed a unique biodiversity on this island. And that is something, there you find things which you find nowhere else on Earth. And here are two examples. These are the lemurs. There are over 40 lemur species, and they are the baobabs. These are perhaps the two most charismatic species, but there are many, many more. So you can actually really say it's one of the world's hotspots of biodiversity. At the same time, Madagascar is one of the poorest countries in the world. And the GDP per capita was, I should say 2020, was $495 for the whole year. And well, 80%, approximately 80% of the population rely predominantly on farming for their income. That means they have nothing else. And they're not big farms, of course. And here you see some photos that we took, that were taken during the project. And yeah, these are the farms, but this is how they do farming in the area we looked at. I would say a bit more about that, but you can already see how simple it is. And this is, I don't know how many they own, but it's not more than a hectare or so. And then they have to kind of feed their whole family with that. And this is, for this area, a rich family, because they have cebu, kind of ox. They have an ox cart, so they're one of the richer ones. There you see the houses. So this is something, you have really poverty there. Okay, and now, because I understand that this is a summer school and I'm not talking all the time, and you should learn something and not listening only, I would like to put you in my situation, or in the situation of our project. And then when we came to Madagascar, where we had, of course, written a proposal, but we also had room for doing our own stuff and doing research and ideas. So I would like you to think now with me. I will introduce you the region and the questions, and then maybe we have a brief discussion whether you can have some ideas what we could do. Why is biodiversity? I'll say like 3 or 4 slides about the case study area. Why is Madagascar, including our case study region, why is biodiversity threatened? There are several reasons, but a key reason is slash and burn farming. And a bit less important is charcoal production. And these are key drivers of deforestation. Africa, Madagascar, and this is our study region, the southwest of Madagascar, the Mahafali region. And we are particularly concerned about the so-called spiny forest, which is a habitat for many endemic plant and animal species. And approximately 90% of the plants in this forest exist only there. Nowhere else on the world, only there. But there's an ongoing destruction due to slash and burn agriculture. And so you have a conflict between conservation, and it's not economic development, it's just food security, as I think I've made it clear. This is a picture of the dry spiny forest. It's really fascinating. I had the opportunity to go there once. It's like a completely different world. This is after slash and burn agriculture. Well, not the agriculture, but the burning. And here, then you have the new fields. And unfortunately, of course, after you burn the forest, the earth is very fertile. But unfortunately, that lasts, okay, they can, if I remember correctly, they can plant corn for maybe 10 years, but then it's always less and less and less. And you have to plant other crops, and finally the soil is degraded. These are two of the charismatic species in the dry spiny forest. Brandidies mongoose, it's highly threatened, and the radiated tortoise is threatened from extinction. These are two pictures just to give you an idea of the communities there. On the top one, that's a village meeting, just under a tree. And in the bottom, that's a house. Again, I should say it's a house of at least middle class or rich men, because it's covered with clay. Okay, so coming back now to my question to you. So we discussed, we were in the region, and we thought about what can we do, what projects can we do. So we discussed the question, can payments from REDD+ could be an appropriate and sufficient mechanism to halt deforestation. And I would like to ignore for the moment all these governance issues, but just think in terms of costs and benefits. What are your thoughts? What may be an argument for payments, what may be against?
Hello? Okay. Thank you very much for your presentation so far. So first my question would be, maybe you can elaborate more what happens with this payment. Is it just money? Because I imagine if you give them just money in somewhere in Madagascar, they cannot maybe do much with the money, so they need some source of to get some food and some other things. So I'm not so sure how remote they are, so even if the money will help. So this would be my question first. And depending on this, maybe these payments don't even work, I would say. Thank you.
That's what I meant, we leave out the governance issues. But of course your question is very valid, and I would like to answer it. What constitutes wealth there? It's the other kettles. Yeah, so you consider whether a man or woman is wealthy. You look at the number of zebus, the number of goats, and the number of chicken, with zebus being the most important one. With respect to the payment, you could, but they do use money. It's just that they can't keep huge amount of money. As you have seen this house, there's no bank. So in this, but we could think of payment as being either a bag of rice or a bag of some food or money. But I think money should be okay. But that's a good question.
Thank you very much. I think money might not solve the question of dependency because their means of production of food are in such a way not environmentally sustainable. So if by giving them money, maybe we will not give them enough knowledge on how to find other ways of producing more accordingly to the type of soil, for example, they have available at that particular region. Or the fact that by having cattle, they're also putting a lot of stress on already impoverished soils. So maybe money would not be the best option by, for example, as I said before, creating a dependency on the money and not solving the real issue, which is creating or developing food security.
Yeah. If I understood you correctly, there was some feedback, so I'm not sure 100% I understood. You were skeptical about the money, with the money being solving not the basic problem of food production, but also it might kind of have wrong incentive that they lose knowledge and all that. Okay. First, if you go there, you realize there's no easy solution. They have population growth. I saw you this mechanism of depletion of soil. We tried to, there was a 10 million project. We had agronomists. They tried to find ways to increase productivity. Either the people knew it already, what they suggested, but within their logic, which was a good logic, but outside of an academic scope, they could well explain why they didn't do it. We identified one mechanism to support that, at least. That was planting samata trees, which so far grew only and were taken, but we suggested to really do plantations, and that can be used as fodder in times of little rain. So there was one idea. So there is no easy solution, and if you ask me, I would honestly say they need food import. Otherwise, and in terms of demotivation, I don't think they don't have enough money anyway. And they would, even if you give them some, they would need to do their production of food in any case.
One of the way could be, first of all, I don't know about the project in detail, so I don't know the project in detail. Can you hear me now? Okay. So normally these monies are channeled through development cooperation. As you said already, you worked with different, some development cooperation or some local operation of the development cooperation. So normally the development cooperation, their project management is based on like, currently they follow the result-based monitoring or result-based project. For example, they are developing, they are making project proposal and they are putting the project on the field and they are channeling the money. This is somehow result-based project. For example, in the beginning, people only took the money, they didn't implement the project. Now, to prevent that, now result-based project management came, for example. So if I see you planted a tree, then you get the money. So maybe this kind of application is already there, but my intervention is later part. So what happens with result-based project management is people only plant the tree, after that, they do not monitor and they do not take care of the plant, how it will survive, So it should be the continuous monitoring at some point that how many trees alive after 3 years, after 2 years, and what are the measures needs to be taken to keep this tree alive. Because you said the little rain, there might not be so much rain, so the tree might not be alive after 6 months if it is not taken care properly. So it should go, in this case, it should go beyond result-based project management so that it can continue. So project does not end after just planting the tree. So it should continue, not only continue the maintenance of the tree, as well as beside a co-benefit could be people from the locality that we should offer incentive to people that they take care of the plant. This is the best model. If they can take care of the model, we, as a developed country people, they will not go to look after that plant, you know. So we need to empower them. We need to create some mechanism so they are incentivized to take care of this plant to start the forest again.
Okay, I think you raised all the important points that I wanted to avoid. Of course, that's very important, but I would like to say that in this case it's not that relevant because we want to preserve the existing forest. Okay, so there's no need to plant new trees, it's just that to stop the decline of the forest. I look at the clock, so maybe 1 or 2 more short questions, then I need to move back to my presentation, yeah.
I have no question. Because we are also doing projects in Africa, in Kenya currently. And in Kenya, I think they are not that poor, but they are facing also the same problem. For example, they cut a lot of the trees and to produce charcoal. I think 2 years ago, the government banned the use of charcoal, but of course the government has also haven't provided any other solution what else they can use. So, and from our project, because we are education institute, and we provided, or we are doing pilot project to use biogas plants. Of course, this idea is quite good, but it's only our idea. We installed the biogas plant, but it is until now doesn't work so well. We installed the same plant in Indonesia. It works perfectly. I think there is still a lack of motivation for the local people to use such a plant or any kind of idea from us. But differently, another biogas project runs very well in the same location. Of course, it's not that efficient as our plant, but still it's in use. And it's also founded by a German institution, and they installed this biogas plant there in the school. And I think in Africa, generally, a school and church plays very important role because it's collect the community, and they will do also communication with the local people, because the people, they have not high education and they don't understand what kind of idea and good idea you have. And the school kids, and they have a little bit of knowledge better than other communities. And this communication effect is actually also quite important in African countries.
I take this more as a comment because I need to look at the clock. I think is that okay? Or there was one question from this side, or? Okay, good. I was thinking completely different. As an economist, I would say, okay, how much can I earn? And you have seen the dry spiny forest. There's very little carbon content, okay? And RED Plus is about paying for carbon content. So there is very little money available for this spiny forest, right? Yeah, so that was my first economic logic, okay? So very little money available. However, so that was the first thing. And then in the beginning we said, okay, no, we don't do that. It's probably not suitable. But then, being economists, we don't only look at one side, we look at the opportunity costs. And given the poverty of the people resulting from very low yield from deforestation, we also said, okay, they might not get a lot of money, but it might be higher then the opportunity costs. So let's do a project and let's calculate, let's compare a possible RED Plus payment with the opportunity costs they have to not to cut down or degrade their forests. Okay? So it's something like a cost-benefit analysis, basically, what we did. Okay, that's basically what we just had. Let me say a few words more about the study region. Is the Mahafali Plateau. It is not that big. It covers approximately 800,000 hectares. It's a semi-arid climate, and annual mean temperature is approximately 24 degrees. Comparatively little rainfall, which is focused just to the rainy season. It's between 300 and 600 milliliter. And you have currently, there's approximately 200,000 hectares of forest under protection, but people don't care, I think because they don't have much choice. But if you look at the deforestation rate, that's tremendous. So between 1973 and 2013, forest loss is 290,000 hectares already. So it's a big problem. The local population is particularly poor, even for Madagascar. So 87% earn below like $200 per year. It's subsistence agriculture, so mixing arable farming and livestock keeping. Crop yields are comparably low, and there's hunger, depending on the harvest and the climate. And smallholders increasingly face drought due to the impact of climate change that can be felt there. So you have slash and burn agriculture, but you have also charcoal production, which degrades the forest. It doesn't destroy the forest completely, but it degrades the forest. People just take out the big trees, tree trunks. And they don't do it regularly because they don't earn a lot with it, in fact, very, very little. But they just do it during the time if they have nothing else to do. So they still earn a bit, but if they find other labor or work on their fields, they don't do it. Okay, so basically how did we do this cost-benefit analysis? We looked at the returns to land, returns to the land, and we compared always 1 hectare. So we looked at 1 hectare of intact natural forest, which can be deforested by slash and burn agriculture, or degraded by charcoal production, or protected. These were our 3 scenarios or alternatives. And of course, for the first scenario, we estimated the profits for smallholders from 1 hectare of forest, assuming that the forest was used for slash and burn agriculture or charcoal production. Okay, then we constructed these 2 comparisons, slash and burn agriculture versus protection, and slash charcoal production versus protection. And we estimated net present values for a typical planning period of a RED Plus project of 25 years. I guess you are familiar with the net present value. It's just that you estimate the benefits of a project over a certain time period, but you take into account that benefit streams occur at different years, so to say, by discounting them. So you have and then you compare it with the cost stream over, sorry, you deduct the cost stream, you have the benefit stream, the discounted benefit, added discounted benefit stream, and then you deduct the added discounted cost stream, and this gives you the net present value over 25 years. So we got the data from literature, but mainly from interviews in the area. We did a lot of household surveys, interviews, and so on. And we have the profit is calculated as the sum of revenues. And so P is the profit, R is the sum of revenues, discounted sum of revenues, and C is the sum or discounted sum of production costs. And we calculated under the red plus scenario. So we assumed that all greenhouse gas emissions that are prevented by forest degradation, that are prevented by forest protection could be used to generate carbon credits. And then we calculated the profits by multiplying S. This is the sum of avoided carbon emissions over the considered time frame. Then we multiplied this with the carbon price for 1 hectare, and then we multiplied this with the carbon price. And then M is the share of the total carbon benefits assigned to the local communities according to some local benefit sharing mechanism. So for example, they don't get 100% because some other money is doing for implementation, is covering implementation costs. Okay, so because I think nowadays for some forests is quite standard, you have some formulas and you can calculate the carbon stock, but here is different. So we had to measure, or the colleagues, the foresters, had to measure the CO2 release, and they focused on above ground biomass. Basically, it constitutes the largest carbon pool. And of course, if there's slash and burn farming, then it gets destroyed. And they did some survey. Basically, they collected relevant data. I don't know how they did it in detail, but they collected relevant data in the national park there. And this enabled them to calculate the amount of carbon that is in the forest in 1 hectare. And I said that earlier, we assumed that for slash and burn agriculture, the whole forest was gone. And for charcoal production, we assumed that the forest was degraded. Then we also, of course, had to select a discount rate if we discount over 25 years. And you may think they're pretty high. We selected 2 as a lower and upper bound, 5 and 20%, but taking into account that there is hunger and people really want to make sure that they live this year and the next year is not so important, rather high discount rate seems appropriate. In order to deal with uncertainties, we used a Monte Carlo simulation approach, so to display the possible range and associated probabilities of results for opportunity costs and the red plus benefits. So basically, a Monte Carlo simulation runs multiple iterations with a deterministic model structure and then randomly samples values from probability distribution of input data, yield, and so on. And as I said, as input for the calculation, we used forest inventory data, got information on land use practices from semi-structured interviews, and price data from market monitoring that was applied in the course of the project. Okay, so what are the results of the analysis? First, the mean above ground carbon stock is, I don't know whether you're familiar with such or you have an idea of data. It's on average 7.9 ton of carbon per hectare. And that is very little. Like other tropical forests have like 100 tons or so. Shall I finish? Okay. Oh, okay. Good. Then let's look at the cost revenue calculation for charcoal production. You have the revenue, US dollar per bag. Bag is huge. You have transport costs, you look at variable costs, you took into account labor time sometimes, because also you can also say people have nothing to do there, so there's zero costs. Of course, considering alternative costs, people could work elsewhere. And then we looked at how much can you produce per hectare, then we calculated profit per bag and per hectare. Okay. Then we looked at slash and burn agriculture. We looked at a typical production, which includes maize, intercropping with mung beans and watermelons. So total revenue, we can calculate the total revenue. Then we have to deduct the costs, which are seed costs, transport costs, variable costs, labor time, labor costs, and we can calculate the profit. Then we calculate the net present values of profits for the alternative use of primary forests in the region. So we have, we compare, we have slash and burn agriculture and avoided slash and burn agriculture through RED+. And you see for the 5% discount rate, it's a bit more profitable to get RED+ money, but that's certainly different for the 20%. Charcoal production, if you exclude labor, here is RED+ is more profitable. If you exclude labor, in any case, even if you include labor, it's slightly more profitable. Here, these are results from the Monte Carlo simulation. So it's shown that for basically, to sum it up, if the curve is more on the right, then it means that in this case here, the red alternative is slightly, the curve is on the right, it means that if the curve is on the right, it means that the alternative is better for the whole, here in this case, for the whole probability distribution. Okay, to sum it up. According to our results of the net present value calculation, the RED+ community profits can outweigh the profits from charcoal production and from slash and burn agriculture by roughly 0.5% of the cases. This implies that payments from RED+, if they ever come, are not fully sufficient to halt forest degradation and deforestation in the Ma'afali region. Of course, the main reason being that not much carbon is saved, despite the low opportunity costs. However, a lot of money is going into Madagascar to conserve biodiversity, and we don't just think of the very low numbers that you have seen. There does not need to be a lot of money going in, and with relatively small top-up payments, you could easily conserve Madagascar. And I was much surprised to learn that there's a lot of conservation going on. I don't know whether the money is spent efficiently, but WWF is, I think, among the 5 biggest employers in Madagascar. That says a lot. So going back to our initial point of this presentation, And are there co-benefits from climate mitigation in terms of biodiversity conservation? In principle, there are, but you can only harvest them to the full extent, if ever, depending on whether REDD+ functions or not, with all the problems that have been mentioned. If you include biodiversity targets in the payments and in the size of payments and how you target payments. Finally, and that goes back to all your comments, things on the ground are always more complicated as suggested by simple cost-benefit analysis. This is my last word now. We had a very interesting experience that people told us, oh yeah, the charcoal production is going up. Why? Because there were some people from WWF, locals, coming in. They had a bit more money. They liked a good meal, and they needed charcoal for that. Okay. Thank you for your attention.
Thanks a lot. As we have already had some discussion before, I would suggest now to have maybe one question right now, and then the rest can be discussed in the coffee break. So is there anyone who... Yes, I see.
Thank you. It's on. Okay, perfect. So I was wondering whether the payments would, like, even though monetarily speaking they're sufficient, they kind of disregard the fact that these people, like, they were subsistence farming, so they were living off the land, and if the land that's already been farmed for over 10 years is no longer viable as farming land, where would they then be getting their food from?
Yeah, that's the big question, and that I think only import could be. I mean, you could have two strategies. One is import, yeah, and that's perhaps unavoidable, but the other one could be to increase productivity. As I said earlier, we tried this with our project. One way was to have samata plantations as fodder in times of drought. Okay, there might be more attempts, but they are not straightforward. So we suggested to do more fertilizer and all that, and the people explained to us why it wouldn't work, and it was convincing. So solutions are not straightforward. It's like a modeling through, but I think, because I think Madagascar, the biodiversity is so valuable, and we did also willingness to pay studies that showed that people are willing to pay, which is for an economist a sign to put money into it, to conserve it, that with a little money, which is needed here, we should conserve this unique biodiversity. It's not a normative statement, but it's based on an analysis and estimation of costs and benefits of this biodiversity conservation.
Wouldn't that realistically mean that the people have to be displaced in the long run because the land they live on isn't really viable anymore? And isn't that unfair for us to decide that this is what has to be done for them?
Yeah, true enough. But well, they couldn't survive anyway. There's 200 hectares left. They can cut this down, and then what's then? Yeah? Of course, you'd have to think broadly. You can think of sustainable tourism. You can think of other options. And the current problem is, or let me phrase it from an economic point of view. You have very often these dilemmata where the costs are borne by few people in terms of biodiversity conservation. The costs are borne by few people, and the benefits accrue to others. And what is lacking is a mechanism that collects the willingness to pay from those who have the benefits and compensate the locals for the costs. And if that would have been done, I think much problems would be solved. Anyway, there's a law that prohibits cutting down the forest. It doesn't work. So it's not that people come and tell you you don't do it. Yeah, it's more complex.
Thank you again for your presentation. We will now have a coffee break until 4:15 and then return to the group work. Dinner will be today at 6:30 in Stadtwirtschaft. Most of you should know by now where it is. And tomorrow, please remember that we will not come back to this place, but tomorrow we will be in Schlossplatzquartier, which is also in the city center. But remember to take all of your personal things and belongings with you when you leave this room today. Thank you. So it is 4:15 now. Please return to your group work. Today you have about 75 minutes to finish your presentation for tomorrow.
it's nothing. Or something else, a report or something. It's just a certain year, but we are not going to publish a lot.
Sorry to interrupt you. We have to finish group work within the next few minutes, please, and leave the room. You know it has to be locked properly on time. Thank you.
Sorry if I also could have your attention just for a second. This is something for the evening event today. You will always have to be either vaccinated or tested by an official testing center. So please make sure, if you want to join today's evening event, that you will have a vaccination pass with you. It can either be, you know, just a document or the online pass, but you will need something because the Stadtwirtschaft, the restaurant we've also been on the first evening, changed their policy as of today, meaning that you will need a vaccination pass to enter, or if you don't have one, which should only be one person actually, then you will need to get tested by a test center. There is one test center in Freiberg, which is in the Ratskeller, where we've always been for our lunch venues. You can get a test there. I don't know how long they will have open for today. Sorry? All right, then this window is closed already. I don't have a solution for those people, but unfortunately, this is out of our hands. We can't do anything about it. If you have a vaccination pass, please bring it with you. Otherwise, we won't be able to get in. Anja, hättest du dann auch noch kurz Zeit zum einmal mittragen?
Ja, sicher, klar.
Schon? Ich habe jetzt nämlich gesehen, hier ist noch ein Stapel von den Blöcken zum Hochstellen.
Ach so.
Ich ziehe gerade nur noch mal alle Präsentationen auf den Stick. Was, die Gläser? Ja, ja, die sind von hier. Die können da bleiben, genau.
Aber das große Flipchart müssen wir noch drüber fahren.
So. Die machen wir gleich hinten aus. Genau. Fängt jetzt wieder an?
Ja, der hat die Stelle, der kriegt die Stelle wahrscheinlich wieder.
Ah. Ach so. Ja, ich hab's nur mitbekommen, mein letzter Stand war, dass es noch nicht ganz klar ist, was jetzt passiert.